from 1970s, only organizations used to generate data. For example, if there is a hospital, this hospital people used to generate data. They used to type, they used to generate data about their patients, they used to generate data about their doctors and so on. And similarly, if it is a college, we used to generate data regarding our students, regarding the faculty, regarding the books in the library and so on. So here in 1970s, only organizations used to generate data. And what happened later? Now from 2000, people also started generating data. Like for example, we have got this smartphones, right? We have got the cell phones, and we are taking pictures from these cell phones, and you are sending it to your friends, sending it to your family members and so on. And similarly, we are sharing this GPS data. Like if you book a Ola cab or an Uber cab, you can share the whole route data to your family members or to your friends for security reasons also, right? And so now here what is happening, not only the organizations, but people also started generating data. And even we have started using Twitter. So many, like 2 lakhs, 3 lakhs tweets are coming per day. And then we are having Facebook. People have started sharing data in Facebook also. They are sharing their photos, they are sharing their texts, they are saying whether they like any post or not, and so on. And similarly, now we are having WhatsApp. Like even though you don't have Twitter or Facebook account, now everyone are having WhatsApp accounts. We are sharing lot many things in WhatsApp also, videos, photos and all. And then now we are having mail, Gmail, Yahoo Mail, and then we are having Flickr. Using Flickr, we are sharing our photos to your friends. And then Skype. Using Skype, you can share the live data, live streaming data. You can see video call of your family members or friends. You can do video conferences. And so like this, not only the organizations, from 2000 onwards, even people also started sharing the data. I mean, generating the data. Now people also have started generating so much of data. And later what happens, now from the past 1 decade, if you observe, now sensors and machines also started generating data. Not only organization and people, now machines also started generating data. How is this possible? It is after the invention of this IoT, machines also started generating data. Now what do we mean this? What is this IoT? IoT means Internet of Things. And now what is this Internet of Things? Like earlier, only people used to connect to internet. Only people, we used to connect to internet, and we used to send mails and so on, right? And that we call it as Internet of People. But now what we can do is, you can connect anything to internet. Anything means you can connect this table to internet, or you can connect the tube light to internet, you can connect the fan to internet, or refrigerator to internet, washing machine to internet. Whatever thing you like, you can connect it to the internet. Now what is the fun of connecting all the things to internet? Like why do we need to connect these things to internet? For that, the best example is smartphone. Now we are using these smartphones, right? Earlier, prior to these cell phones, we used to have red button and green button cell phones, right? Now what is the major difference between that red and green button cell phone and this smartphone? Yes, what is the main difference? Here in this smartphone, we are able to connect this cell phone to the internet. So now what is the advantage we got after connecting this smartphone to internet? Yes, we are able to do online shopping, online banking, online purchases, and then e-learning, m-learning, you are learning through mobiles, and then entertainment. Lot many things are happening once you have connected just one cell phone to your internet. Okay, so this is IoT device now. Then just imagine if you can connect all the things like tube lights or fans or everything to internet, then just imagine how many advantages we can get. And one more thing we need to observe is, here now after connecting the phone to the internet, now your phone also started generating data. Right? We are taking photos, we are sending to someone else, we are generating data regarding our purchases, we are generating data regarding our online banking and so on, right? Similarly, if you can connect a tube light to the internet, what happens if I connect my tube light which is at my home, then even though if I am away from my home, then also I can switch on the tube light or switch off the tube light even from my college. How is this possible? Because I have connected my tube light at home to the internet, and then I am having internet in my smartphone. Now using the smartphone, I can switch off the light at my house, right? Similarly, I can connect all refrigerators or anything to the internet. And one more example is smart mirror. Like your smart mirror, like we are already having these smart mirrors, and maybe in future we may have the smart mirrors will be available with less cost and maybe very much available. And what are the smart mirrors? What are the smart mirrors means, if you just stand before the smart mirror every day morning, it will give your total health profile. Health profile means it will give your thyroid profile, it will give your kidney profile, it will give your liver profile, and it will tell how is your BP, how are your insulin levels and all. Now how is this happening? How can it tell? For that, initially they will just inject a small dot size chip into our skin. Like they will inject one small very dot size chip into our skin, and later throughout the life, if you just stand before the smart mirror, your total health profile will be displayed. Okay. Now just imagine your mirrors also started generating data. Your phone started generating data, your mirrors started generating data, your refrigerators are generating data, your TVs are generating data, and so lots and lots of data is being generated, and so quintillions of data is being generated, which leads to the problem of big data. Now what is big data? Data beyond to the storage capacity and beyond to the processing power of our technology is called as big data. Okay, that means suppose if you are having this much of capacity and our data is this much, that means that is big data for me. Like for example, in my laptop, if I am having 1 TB data, then if I have to store some 800 GB data, then that is not big data for me. But for example, if you are having some 500 GB hard disk, and if you want to store 1 TB data, then definitely it is a big data for you. Okay. So data beyond to the storage and processing capabilities of our technology is called as big data. Now let us see what are various characteristics of big data. Volume, variety and velocity. We call them as 3 V's of big data, and all these 3 are the characteristics of big data. And later, so many scientists, they have given many other V's, like now we are having some 30 V's or 40 V's, like active velocity, we are having veracity, viscosity and all. But the basic 3 core characteristics of big data is volume, variety and velocity. So now let us see in brief what do you mean by volume. We all know that volume is amount of data. That is, the data is increasing in its volume, like from KBs and MBs. Earlier we used to have just KB and MB data, and now we are having zettabytes and yottabytes of data, some ZB and YBs of data. Like for example, if you observe, even in 1990s, we used to have these floppy drives. Using these floppy drives, we can store only up to some 340 KB or 1.4 MB data at that time. But those floppy data are sufficient for that time. But now if you observe, even though if you are having 1 TB or 2 TB hard disks in our laptops or computers, we are still storing our data in clouds. Cloud means we are storing the data on someone else's computer, maybe on rent basis, and to some extent today, cloud storage is also free, and later we have to pay some rent and we have to store it. So now just imagine, then even though we are having some KBs of storage devices which can store only some KB, that is sufficient at that time. Now even though we are having some TBs of hard disk, that is not sufficient to store our data. So this itself shows how the data is growing. So volume is one of the major characteristics of big data. Now let us see, second thing is variety. Variety, okay, we can classify this variety as image data, text data or video data and so on. Or another classification we can say is, we can classify the variety of data as structured data, unstructured data and semi-structured data. Now let us see what do we mean by structured data. Structured data means Structured data refers to information with a high degree of organization. That means your data is totally organized. Like for example, all tables of relational databases is structured data, because here you are having a proper schema. Like you will say that all the records of this table will contain first column as employee number, second column employee name, third column designation, and so on. So even the first record, or even though if you store some 1 lakh records or 10 lakh records, even 1 lakh record also, you will have the same schema. Like first column you will have only the employee number. So if the data is so much organized, that means if the data is structured data, then it will be very easy for us to handle that data. For example, if you want to search anything, you can search very easily using structured data. If you want to read one record, you can read it very easily if it is a structured data, because prior to hand you will know the length of the record. Let us say length of the record of one particular table, let us say what I have shown is some 100 bytes. Then if you want to read some 10th record, so 100 into 10, directly you can go to 1000th record and you can read the 10th record. Like that it will be easy to handle whether to or process the structured data. But now in this real world, we are not only having structured data, we are also having unstructured data and semi-structured data, and most of the time, 80% of the time nowadays, we are having unstructured as well as semi-structured data. Now let us see what do we mean by unstructured data. Unstructured data means it is the data that either does not have a predefined data model or is not organized in predefined manner. That means it will not have any predefined structure. It will not have any table kind of thing. You will not have any header. You cannot say that now your data will come only in this format. Okay. For example, mail. Mail is an unstructured data, because you cannot predict how it comes. One mail it will be 1 sentence long and another mail it will be 100 sentence long. And then Facebook, you cannot predict the Facebook data also. You cannot say that this Facebook in Facebook, like first you will receive only photo and that will be only of this size, and then you will receive text. Nothing of that sort. Anything can come at any time. You may get some photos and later you get some videos, or like get some text and later you can comment on something, you can like something, you can dislike something. It is totally unstructured. So Facebook data is also unstructured data. And then similarly video files, audio files, and then word files, all this is unstructured data. Now let us see what do we mean by semi-structured data. Semi-structured data means, as the name says, as the name itself implies, it is neither structured data nor unstructured data. It is not structured and not unstructured. It is an intermediate, in between thing, right? Now what do we mean by semi-structured data? Definitely it will not have a proper format. You cannot say that we are having this schema for this table, no. And also it is not totally unstructured. Here we will have some begin and ending kind of things, begin and ending kind of things. Like for example, HTML, XML and JSON records are all semi-structured. For example, if this is a JSON record, example of a JSON record. In JSON what will happen is, this is the first record. How you will define the record is like this. Like here, initially there will not be any schema, but here you will give the metadata and then the value. We will say employee ID is 100, employee name is Kiran, salary is 60,000. Like this, if you want to insert the data, we have to give like this. Okay, and then second record, it can have only 2 columns, employee ID and employee name, and maybe the third record it can contain some 10 columns. Like that, it may have, it will not fix to a proper schema or proper heading of the table. You can have any number of columns for different records, but still here we can say that this is the first record and this is the second record. We are having the beginning of the record and then the ending of the record. That's why we can say that this is semi-structured data. And similarly, HTML also, if you write observe HTML programs, we will be having a starting tag and an ending tag. In between, you do not know. This paragraph may be 1 line length or maybe of 100 line length. So HTML programs are also semi-structured data. So like this, we are having structured, unstructured and semi-structured data. Like earlier, because only organizations used to generate data, they used to generate only structured data. They used to give data only maybe in the form of tables, and then we used to have only structured data, and it is easy, as we already seen, as it is easy to handle structured data. At that time our traditional technologies are sufficient, and we were able to work and we were able to process all the necessary data. But now what is happening, as we have observed, now as people also started generating data, and as sensors also started generating data, huge amount of data and huge variety of data are being generated, structured as well as unstructured, and so now traditional technologies are not sufficient to handle this data. It is very difficult to handle unstructured or semi-structured data. Now let us see the third characteristics, that is velocity. Velocity means frequency of incoming data that need to be processed. How fast the data is coming to you, that is called as a velocity. Say for example, if I give you one textbook, if I give you one book, and if I ask you to, okay, keep this book with you and you please return me whenever I ask you, okay, what you will do? You will take that book and you will put it at your home, okay, fine. And next day what I will do is, I will give another book to you. I will give another book and I will ask you to put it at your home, okay, you will take it. And then third day what I will do is, I will give some pile of books, not one book, now I am giving pile of books. So what you will do? Okay, you will carry all those pile of books and then you will put it at your house, right? And then next fourth day again I will give one more pile of books, okay? And then fifth day, let us imagine I will give you one truck of books, okay, so many books, one truck of books. And then maybe next hour itself, may not be next day, next hour itself, I will give one more truck. And maybe within next 10 minutes, I will give 5 trucks of books. So what will happen? Yes, your house is houseful, right? You cannot store any more books in your house. You have to look after some other house for rent to store my books, or for some other go down, and so on. And also the processing also will be difficult. Like if I ask you, okay, get me that big data textbook, then what you have to do? You have to search in all the books what are all with you, and it will be very difficult for you to search, right? So now this is the effect of the velocity. Like if velocity is low, that means if you are just sending one text file now and then, or if you are just sending one photo now and then, now maybe that may not be a problem to store or process the data. But if you are getting live data, streaming data, and if you have to analyze that streaming data also, then definitely our present technologies cannot handle that problem. So this is velocity, and all these three are the characteristics of a big data: volume, variety and velocity. Now let us see what is big data. We will see once again another scientist, he says that big data is high volume, high velocity, high variety data sets which cannot be processed with traditional computing techniques. That already I have told you. Like another scientist, they define big data as a huge volume data, high velocity data, high variety data which cannot be processed with traditional computing techniques. And then finally Gartner, he is the scientist who have given this definition, and he says that big data is a high volume, high velocity and high variety information assets that demand cost-effective, innovative forms of information processing for enhanced insight and decision making. And okay, let us break this definition for you. We'll explain it like this. He says that it is a high volume, high velocity and high variety data, and this data it needs some cost-effective and innovative forms of processing. That means if you want to process this high volume, high velocity data, you need some processing systems which are cost-effective. That means which are not of very high cost. Okay, and then why do you need to process at all? We need to process this data for enhanced insight and decision making, for it should help in some decision making. Like for example, if we have some very good data, and you can definitely process the data to get the information, and you can analyze that information to improve your knowledge, and now with that knowledge if you take the decision, that will be a very good decision, or that will be a better decision instead of taking a decision without data at all, right? So this is what big data is. It is high volume, high velocity, high variety data which needs some cost-effective forms for processing for enhanced insight and decision making. Now let us see what do we mean by big data analytics. Okay, now let us see what is big data analytics. What does big data analytics means? Like for example, earlier if you want to go for a movie, for example, then what we used to do, we used to ask our neighbor or we used to ask our friends about which one is a good movie, and we used to go to that movie, right? But now what we are doing, okay, along with asking with neighbors or friends, we are also searching in Google. We are also searching in internet, and we are finding out the reviews about the movies. Like as by seeing those movies reviews, you can decide which movie suits you and you can go for that movie. Right? And similarly, if you want to purchase something, if you want to purchase a car, or if you want to purchase a phone, now what you will do? Okay, you may have only one or two friends who are having one particular car, but now if you search in Google, what happens? You can get so many reviews, and you can get the ratings of those reviews also on Google, on internet. Now by seeing those reviews and ratings, you can decide which car to purchase, right? Now how are you getting these reviews? How are you getting these ratings? Again, big data analysis. Big data analytics is happening. Like already you may be having so many other people who have already bought that car. Then they'll write their experiences, they'll give their feedback, they'll give the feedback to the companies, or they can write it on Twitter to their friends that this car is very good for this reason and this is not so good, maybe the ground that is touching the ground or something like that. They can write their reviews on Twitter or Facebook or anything. And now if you do a proper analysis, now you can get the ratings and reviews about those cars, and you can go for purchasing that particular car. Right? And then one more example is, like for example, today if I have done some online shopping, I have done some online shopping, and suppose for example I have bought one dress, okay, and next day if I open my Gmail account, I'll get the ads relating to the dresses only. If you observe, like if you open the inbox, to the right of the inbox you will get the advertisement related to the dresses. For example, if you buy some phone, and next day if you open your email, then you will get the advertisements only related to phones. Okay, now how is this happening? Like I am not the only person who is having mail accounts, I am not the only person who is doing online shopping. There are crores and crores of people who are doing online shopping and who are purchasing the things, right? Now big data analytics is being done, like so many people are there. So for every people they are observing what are their purchase patterns, what are their buying patterns, and they are giving customized advertisement for the customers. They are seeing, okay, for whom it is necessary they feel, and only for those people they are giving the advertisements, right? So how is this happening? This is all happening with the help of big data analytics. Like one more example is, for example, if I have some company, some organization, and let us say actually I have got some 20 lakhs profit, but what I will tell to the income tax department, I may tell that, okay, I got some 10 lakhs loss, so I will not pay a single pie to the income tax department. Now what is happening, or what could happen in future? Now we are linking our Aadhaar number to each and everything. They are asking us to link our Aadhaar number to the bank account, and they are asking to link Aadhaar number to my cell phone. They are asking me to link my Aadhaar number to the RTO office. They are asking to link the Aadhaar number to the registration office, and even you have to give your PAN number also if you have done a major purchase in gold shop or something like that, right? Now what may happen in future? Now a big data analysis could be done on every person, each and every person from the income tax department, and one day they can give me a show cause notice saying that, okay, you have purchased this particular flat in this particular area, and you have purchased so and so vehicle, so and so car, and you are showing 10 lakhs loss. So just tell me, where did you get money to buy all these things? That is a show cause notice I may receive from the income tax department. So this is what is big data analytics. I mean, after doing so much of analytics, you can draw some conclusions and you can identify some patterns. Like for example, if we see in detail, what does big data analytics means? Big data analytics uses data and different other techniques, some IT techniques and features of statistics, quantitative methods and different other models to draw the conclusions and provide results. Like as I have told you, like it uses so many IT techniques and statistics and quantitative techniques and anything, and it will identify the patterns and it will draw some conclusions, and that we call it as big data analytics. Okay. Now, big data analytics reform the ways to conduct business in many ways. As we have already seen, like big data analytics, it reformed the ways to conduct the business. Like earlier, we used to have only physical shops. Now we are also slowly shifting. We are having both online purchases as well as offline purchases. And also the business people, they are observing our buying patterns, and depending on our buying patterns, they are giving the advertisements, and maybe depending on our buying patterns, they can give you certain discounts, and maybe they'll observe which people are buying which products and what are their likes and what are their dislikes, and maybe they'll use this information for future product invention of a future product design. Okay, and then it improves decision making, business process management, etc. Big data analytics, they are saying it improves decision making, business process management, etc. For this, a best example is like AP government, like Andhra Pradesh state government. What it is doing is, it has installed many IoT devices in almost all mandals to know the level of the groundwater. Okay, so every hour, every day, every hour, the groundwater level data is being uploaded to CM dashboard. This is already happening. Okay, now with this data in hand, they can do some analytics. They can do some analytics and they can find out like what are the areas where the groundwater is very low, and then they can take some measures to bring that groundwater level up. Okay, they can plan to construct some check dams, or they can plan to motivate the people and so on. Okay, and one more thing is, okay, they are having this groundwater level data, and also they are having the water level in the reservoirs data also. Water level in reservoirs, like what level the water is there in the reservoirs, and then they are having the crop data also, like in which villages or which mandals which crop is growing. Okay, now integrating all these things, all this data is being uploaded to CM dashboard now, and so if anyone can do a big data analytics on all these things, then they can take very good decisions. Like for example, they can say to which canal they need to release water now, and how much of amount of water they have to release. Okay, ఏ కాలువకి ఎంత నీళ్ళు వదలాలి, అలానే ఏ కాలువకి ఏ రోజున వదలాలి, ఎప్పుడు వదలాలి, సో ఎంత వాటర్ వదలాలి, ఎటువైపు వదిలితే ఆ వాటర్ వేస్ట్ అవుతుంది. సో ఆల్ దీస్ డెసిషన్స్ దే కెన్ టేక్. Okay, so in this way we can say that big data analytics, they improves decision making and business process management, etc. Right, and then big data analytics also helps in fraud detection. Fraud detection means, like one example is, let us say I am having some credit card or debit card. Okay, and let us say from past 5 years I am using this debit card, and for till now, whatever transactions I have made, the maximum amount I spend on the transaction is, let us say, 10,000 rupees. Okay, from past 5 years I haven't bought anything which is more than 10,000 rupees. Okay, now okay, one fine morning someone has stolen my password or stolen my card, and maybe they try to draw some 4 lakhs rupees from my credit card. Then what it will do, the bank people, they are already doing it, they are doing some big data analytics, and I'll get an alert message, and it says that if it is you, it's okay, and if it is not you, please contact your bank and immediately block your card. So how is this happening? Like they have to observe each and every customer. Customers, you will be having crores and crores of customers. So they are observing each and every one's data, and then they have regular patterns they'll observe. And if something falls outside this regular pattern, we call them as outliers. Okay, then definitely you can take some action on the outliers. And similarly, even for criminal analysis also, this big data analytics is being used now. Okay. And now let us see, okay, this we are having big data analytics, and we have already told that it is technology enabled analytics. That means you will use computers or so much other big data technology and everything for these analytics. And then it works with the data sets whose volume and variety are beyond the normal storage and processing capabilities. This is the main thing. Like big data analytics means it has to work on huge data, various varieties of data like structured data, unstructured data, and then it has to work with various velocities of data also. And then it has to better and faster decisions in real time. Yeah, very good example for real-time analysis. For real-time analysis, a very good example is like driverless car. Like people are saying that driverless cars are now in trial phase, and maybe within a very near future we are going to get these driverless cars. Now this driverless car, imagine, now it has to do real-time analysis. For example, the car has to move, the car is moving on the road, so it has to get the data about the live data. It has to get the live data about live videos about the road on which it is going. It has to observe the objects what are there on the road. It has to observe the vehicles. It has to observe the passengers and all. And then it has to get the live data, and on the go itself immediately it has to do some analysis and it has to take the decision. Like if there is some vehicle in front, then definitely it has to take the decision that it has to stop, or it has to take decision that it has to go right side or left side. So all this is real-time analysis. So big data analytics is also very much useful for real-time analysis. And then competitive advantage, and then big data analytics, it provides richer, deeper insights into customers' patterns and the businesses. Like as we have already seen some example, big data analytics, it will provide some deep insights which are not visual, which cannot be visualized normally, and then it will help in taking some decision. Okay, and now let us see various types of big data analytics. We are having various types of big data analytics. First one is descriptive analytics, second one is predictive analytics, and third one is prescriptive analytics. Now what is descriptive analytics? Descriptive analytics means like it serves as the base for advanced analytics, and it says what happened in the business. Like for example, it will just say, the descriptive analysis, it will just say that, okay, what happened in place A, what happened in place B, and what happened in the place C, and it serves as the base for the next analysis. Okay, like for example, if we recollect our smart mirror example, as I have told you, if you just stand before the smart mirror, it will give your health profile every day morning. Like for example, if I am using my smart mirror from past 10 years, okay, let us assume that I am using my smart mirror from the past 10 years. Okay, so now my descriptive analysis could be, what it can say, it can do some big data analytics, and it can say that, okay, from the past 5 years, your thyroid profile is normal, your kidney profile is normal, your liver profile is normal, and maybe your BP is slightly going high, and so on. This is descriptive analytics. Fine. Now let us see what do we mean by predictive analysis. As the name says, predictive analysis means it will answer the question what could happen. Like it has to understand, and it has to understand the present and past situations, and it has to predict the future. For example, in our smart mirror example, what my smart mirror can say is, by observing the data, it can tell that, okay, within 5 years you are going to get a heart attack. Okay, this is a predictive analysis. Now how could my smart mirror say that within 5 years you are going to get a heart attack? How can it say? It will tell that by observing my data and comparing my health profile with so many other health profiles. Like for example, just after some few years, let us imagine that many people are using big data. Let us imagine that some 2 lakhs and 4 lakhs people are using big data, and they'll be having so much of data, their health profiles every day. They'll also will be having their own health profiles. Now what your computer will do, what your big data analysis we can do is, it will compare my health profile with all some 3 lakhs, 4 lakhs people's health profiles some 10 years back. ఓకే, అంటే ఈ రోజు నా హెల్త్ ప్రొఫైల్ని ఎవరన్నా ఒక 2 lakhs పీపుల్ ఎవరైతే స్మార్ట్ మిర్రర్స్ వాడుతున్నారో వాళ్ళ 10 years ప్రొఫైల్తో కంపేర్ చేస్తుంది, 10 years బ్యాక్ ప్రొఫైల్తో నా ఇప్పటి ప్రొఫైల్ కంపేర్ చేస్తుంది. చేస్తే లెట్ us say that it finds some 10,000 people who are having the same health profile as mine some 10 years back. ఓకే, 10 ఏళ్ల క్రితమే ఇవాళ నా హెల్త్ ప్రొఫైల్ ఏముందో వాళ్ళకి 10 ఏళ్ల క్రితం అదే హెల్త్ ప్రొఫైల్ ఉంది. దెన్ వాట్ ఇట్ కెన్ సే, okay, among those 10,000 people, let us imagine, let us assume some 9,500 people got heart attack after some 5 to 6 years. Then what, now it can predict to me, the big data analysis, after doing all this big data analysis, now it can predict, my smart mirror can say that you are going to get a heart attack within 5 years if you proceed in the same manner. Okay, if you don't take any precautions, you are going to get a heart attack. This is a predictive analysis. Fine. Now let us see, what do you mean by prescriptive analysis? Prescriptive analysis means once the prediction made, now what should we do? That is the prescription, prescribes the precautions. Now what my smart mirror can do, once it understands that I am going to get heart attack within 5 years, it will tell me the precautions, like okay, every day you have to do walking or eat this thing, do not eat this thing. This is prescriptive analysis. Okay, so these are various types of analysis we have. And now let us see what are various big data tools available in the market to handle this big data and which can provide some big data analytics. Okay, like there are so many tools like Hadoop, Hive, Cubole, Cloudera, Flink, Refine and all these tools can handle big data and perform some analysis. Okay, and in our syllabus, as we are having Hadoop, now let us see, let us introduce Hadoop and let us see a brief introduction on Hadoop. Okay, now let us see a brief introduction about Hadoop. Then Hadoop is a framework for storing, processing and analyzing big data. Hadoop is a framework for storing, processing and analyzing big data. That means Hadoop is one solution with the help of which you can store big data, you can process big data and you can analyze big data. And then it allows distributed storage and distributed processing of large data sets across clusters of computers using a simple programming model. Like as you can see, big data means we are having huge volume of data, right? Big data means we are having huge volume of data. And if you ask the whole thing to be stored in one computer, it is not possible, right? So that's why what it will do, Hadoop will use distributed storage. That means what it will do is, whatever data you have, the huge data, it will break it into blocks, equal sized blocks. It will break it into equal sized blocks and maybe it will store some 2 blocks in one computer, some 5 blocks in second computer and maybe 3 blocks in third computer and so on. Okay, the whole big data will be broken into blocks and those blocks will be stored in not one computer, in many computers. This is called as distributed storage and Hadoop does this. Hadoop does this distributed storage. And not only distributed storage, Hadoop also do distributed processing. Distributed processing means, like for example, if I have to construct a wall, okay, if I have to construct a wall, then if I ask one person to construct the wall, let us imagine that it takes some 10 days. Fine. Now if I employ 10 persons, 10 men can maybe they may complete it in 1 day, right? So similarly here, Hadoop also, to handle a very big data, to handle various varieties of data and to handle the various velocities of data, what it will do is it will do distributed processing. Instead of one computer processing the whole thing, it will give the task to many computers. It will divide the task to many computers and all the computers together can process the things. And also Hadoop is designed to scale out from single servers to thousands of machines. This is very important concept of Hadoop, that it scale out. Here we have to explain the difference between two things, that is scale up and scale out. Scale up means like improving the performance of the same system, we call it as scale up. That means, say for example, if I am having a server and let us say my server capacity is some 2 TB hard disk, and today I am having let us say 1 TB data. So as I am having 2 TB hard disk, no problem, I will store that 1 TB data in my server. Fine. Then after some time I will get my data will be 3 TB. That I am having only 2 TB data. What I have to do? Okay, I will use some external hard disk. I will buy some other hard disk which is of 2 TB capacity, and I will manage it. Okay, the 3 TB data I will put it in my system, and after some time you will get some 10 TB data. Now what to do? You cannot improve the performance of a system beyond some capability, beyond some capacity, right? This process is called scaling up. But Hadoop will not do this. It will scale out the thing. Scale out means, like for example, in the same example, okay, if I am having 2 TB hard disk and if I get some 3 TB data, if I have to store some 3 TB data, instead of getting an external hard disk, now I'll buy one more computer. Okay, I'll buy one more computer and I'll put the data on that, and these two computers together will work. Okay, these two computers, using these two computers together, I'll store the data. Using these two computers together, I'll process the data. And okay, then later after some time I'll get 10 TB data. If these two computers are sufficient, it's fine. Otherwise, I'll buy one more computer and I'll add it to it. Like that, Hadoop can run on a single server, or you can go on adding thousands and thousands of computers. Okay, so that's why it is written, it is designed to scale out from single server to thousands of machines. Okay, and then if we look at Hadoop vendors, who are Hadoop vendors and what are various types of Hadoops we have? Okay, Works is one of the Hadoop vendor, Cloudera, MapR Technologies, Microsoft, Apache Hadoop, and so on. All these things, the above things are commercial and we need to pay something to use these things. But Apache Hadoop, as you see, Apache Hadoop is an open source framework. You can directly download it from the internet and you can use it. Apache Hadoop is a open source framework and you can directly download and can use it. Fine. And now let us see what are the core components of Hadoop. Hadoop accomplishes these two tasks, like Hadoop will have massive data storage and it has to provide faster and distributed data processing. So how Hadoop will accomplish this? First, okay, it can store huge amounts of data only with the help of Hdfs. Hdfs means Hadoop Distributed File System. Hadoop will have one component called as Hadoop Distributed File System. We'll commonly call it as Hdfs, and with the help of this Hdfs, any volume of data can be stored in Hadoop. Okay, and then for faster and distributed data processing, Hadoop will use the concept of MapReduce. Okay, with the help of this MapReduce concept, the processing will be done. Okay, so Hdfs plus MapReduce is equal to Hadoop. Hadoop, the basic two important concepts of Hadoop are Hdfs and MapReduce. We are having so many other components, but the first two basic components are Hdfs and Hadoop, MapReduce. And now Hadoop is based on master-slave architecture. Okay, this is one more important feature of Hadoop. It is based on master-slave architecture. Now, what do we mean by master-slave architecture? We'll have one computer and we'll call it as master, and we'll be having so many other computers, we'll call them as slaves. Okay, now your master will give instructions to slaves, and slaves have to follow all the instructions given by the master. Okay, and also unlike client server systems, here your clients also, your slaves also will send heartbeat signals to the master. Slaves will send heartbeat signals to the master in some regular time intervals. Maybe for every second your slave can send the heartbeat signal. What do we mean by heartbeat signal? Like master will not know whether the slaves means slave is also a computer, master is also a computer, and this master will not know whether the slave computer is active or whether it is down or whether it is dead, right? So that's why if it do not receive the heartbeat signal from one slave for a long amount of time, means okay, it will understand that there is some problem with that system, and so it will think of the other alternative methods. Okay, so Hadoop is based on master slave architecture, one master and many slaves. And now HDFS, if you briefly see, it is a storage component, as we have mentioned. It distributes data across the nodes. Yes, it needs so many computers, and it will divide the data into blocks, and it will allocate the block to each computer. And then this is another important feature is it is natively redundant. It stores 3 replicas for each block. Like every block is stored in 3 different places. That means it will keep 3 copies for every block. One block it will save on one computer, and the copy of the same block will be saved on 2 more computers. Why? Like if the first computer fails for some reason, if it goes down, then Hadoop will definitely, it can use the other 2 copies. And so even though the system, you will have system failures, here will not have any data loss. And this is a major feature of Hadoop, the reliability. It gives a lot of reliability for its customers. Okay, and then now let us see the architecture of HDFS. This is Hadoop Distributed File System Architecture. Okay, here you are having so many computers. We call them as data nodes, and on these computers, these are all slave computers, and on these data nodes you can store the blocks. Okay, in first first data node, I have stored some 3 blocks, and second data node I have stored some 2 blocks, and so on. Okay, you can store any number of nodes, and as I have already told you, one block if you save in first computer, the same copy you have to save some at 2 more places, maybe in third computer and fourth computer. Okay, and then now how you will know that which block is saved in which computer, right? Which block is saved in which data node, how you will know? For that we are having here name node. Name node is the master computer. Okay, we'll put this name node in master computer, and this master name node can give instructions to all its slaves, and this name node will record that log file, will store that log file, that which block is allotted to which computer, and the copy of this block is where it is available. All this data your name node will be handling. Okay, and then now just imagine if that name node fails, if this name node fails, then how? For that reason we are having a secondary name node. Okay, in secondary name node is exact copy of name node, and whenever this name node fails, then the secondary name node immediately takes charge. Okay, it takes charge and it will start acting as the master, and it will send the signals and instructions to its slaves. And then, as I have already mentioned, these data nodes, these slave computers, they have to send heartbeat signals back to the name node. Every second, let us say for example, in some unit interval, they will send the heartbeat signals, so that name node will come to know that which computer is working and which computer is not working. So this is the architecture of the HDFS. Now let us see what is MapReduce. MapReduce will use it for processing, for parallel data processing. And we are for this, let us take this word count problem. Word count problem means, suppose let us say we are having a computer science textbook. I have given one computer science textbook for you, and let us say it is having some 10,000 pages. Then if I ask you to count the word computer, how many times the word computer has occurred in that whole textbook, if I ask you to count, and if I ask only one person to count, let us say it takes 10 days. Okay, now instead of wasting 10 days, what I can do is I can divide these 10,000 pages, and I can give some 1,000 pages to one person, second 1,000 pages to second person. Like that, if I employ 10 persons, if I give 1,000 pages each to each person, then we can complete this task within one day, right? The same system will be followed in MapReduce. Same system will be followed by the Hadoop. Let us see here, like this is architecture of the Hadoop for writing the MapReduce program, and here we'll be having some mappers. Mappers means these are also computers like slave computers, and we'll have one reducer. Reducer is also a computer. Okay, now what we'll do is we'll give first 1,000 pages to one computer, second 1,000 pages on another computer, third 1,000 pages to another computer, and so on. okay, and I'll write a routine here, I'll write a program here, a mapper routine here in this computer, asking it to count how many times the word computer has occurred. So the same program will be run on all these three mappers. ఈ మూడు కంప్యూటర్స్ లో కూడా అదే ప్రోగ్రామ్ రన్ అవుతుంది, and this program will find out that there are 100 times the word computer has repeated in first 1000 pages, and this computer will find out that in these 1000 pages, okay, 152 times it has the computer word has occurred, and this sum 200 times, and then now here we'll be having one more computer called as reducer. Now what this reducer will do is it will take the output from all the mappers and it will combine the data and then it will give it as the output. So now it will say that we are having some 452 times the computer word has occurred. So this is parallel processing, okay. Using this map routines and reducer routines, the whole parallel processing can be done. And here number of reducers, you can have 2 reducers or 3 reducers depending upon our program. Like you can have 2 reducers here. If I asked you to count computer, how many times computer has occurred and how many times some input device has occurred, you can ask one reducer to count number of computer has occurred, and you can ask another reducer to tell how many times another word has occurred. Fine. And now, as I have told you, these two are the basic components. Hadoop has basic components is Hdfs and MapReduce, and now let us just see what is Hadoop ecosystem. Hadoop ecosystem means it supports projects to enhance the functionality of Hadoop core components. Along with Hdfs and along with this MapReduce programming concepts, Hadoop also has so many other tools to help with. Like if you want to take data, so much of big data has to be given to Hdfs. So to enter the data from the real world into Hdfs, they will use the scoop and flume. And similarly for big data analytics, we use either pig or hive. And then the zookeeper, it will act as a coordinator for the whole thing. It coordinates all these projects. And then Oozy, it is the workflow scheduler. Like it will tell first it has this thing has to be happen, and second this thing has to be happen. And so these are the other components which in total we call them as Hadoop ecosystem. And now let us see what we have done in this class. First we have seen what do we mean by big data, and then we have seen what are the characteristics of big data, and then we have moved to big data analytics, and then we have seen the types of analytics also here, and then we have seen various technologies available to handle big data, and then we have have a brief introduction about Hadoop, and then we have seen the Hadoop components, Hdfs and MapReduce, and then finally Hadoop ecosystem. So, and these are the references.
Good morning students. In this presentation I am going to discuss about 3 different topics in spectroscopy which we are going to study in one of the cluster papers. The first topic I am going to discuss is Fourier Transform Nmr Spectroscopy. Fourier Transform involves the conversion of a time domain to a frequency domain. So what is time domain? Time domain is nothing but a plot between the intensity and the time, which is measured in seconds. Whereas the frequency domain is a plot between the intensity and the frequency. So let us understand how the Fourier transform is carried out and what is the importance of Fourier transform. Let us consider this particular percussion instrument known as tubular chime. It contains a series of bells, and each bell can be, as seen in the figure, each bell can be struck with a wooden hammer, and each bell will produce its unique and characteristic sound. Therefore, each bell when struck with a wooden hammer will produce a sound having a unique and a characteristic frequency, and the frequency of one bell does not match with that of the other. So if you select only 4 chymes and stroke them, then you will get the pattern like this as shown in the figure. This is for the first one, this is for the second one, third one, fourth one. Instead of striking them individually, if we strike the 4 chymes at a time, then the patterns, sound patterns of all the 4 will be interfered and will form a complex interferogram as shown in the figure. So, how we get the frequency information from this interferogram? This can be done by using the Fourier transform. And Fourier is a scientist who has first carried out this particular conversion from time domain to frequency domain. And he has studied the relationship between a complex interferogram and the set of sine and cosine frequencies. Therefore, if you take that particular interferogram, when we obtain by stroking 4 chymes at a time, then that can be converted to, that means that can be Fourier transformed to this particular frequency domain. You can see this frequency domain contains 4 different frequencies having different intensities. Therefore, the Fourier transform is a very good method to convert a time domain to a frequency domain. Therefore, from the complex interferogram, if you want to obtain the frequency information, then Fourier transformation will offer or Fourier transform will offer a very good method for this conversion. Then why we have to study Fourier transform in spectroscopy? Because several spectroscopy methods are there, like NMR and IR, which we commonly use in the organic chemistry lab. These will produce complex interferograms. Therefore, these complex interferograms are very difficult to interpret because the frequencies will match and they will interfere with one another, and they will generate a complex interferogram. Therefore, to obtain a meaningful information from the spectrum, before getting the spectrum, we have to convert the complex interferogram into a frequency domain plot. I will explain about this in the next slides. There are basically 2 types of NMR spectrometers. Now I am going to concentrate only on the Fourier transform NMR spectrometer. There are 2 types of NMR spectrometers. One is continuous wave and second one is Fourier transform. Then what is continuous wave spectrometer? In the continuous wave spectrometer, we use either a frequency sweep or a magnetic field sweep. Generally, we keep the magnetic field constant, or we can keep the frequency constant. In the frequency sweep, we will change the frequencies and the magnetic field is kept constant, whereas in the magnetic field sweep, the magnetic field will vary, the frequency will remain same. In most of the continuous wave NMR spectrometers, the frequency is kept constant, whereas the magnetic field sweep is carried out, and each and every proton in the molecule is brought into resonance one by one. Therefore, it is a time consuming process. It means we have to choose the stationary magnetic field in such a way that the alarm frequency of the proton matches the applied frequency. Therefore, each and every proton has to come into resonance one by one. Therefore, it will take a lot of time for the accumulation of data from different protons. And instead of that, if we can use the Fourier transform NMR spectrometer, then we can save the time, and also it is highly sensitive technique. And this Fourier transform NMR technique was first introduced by Ernst, who got the Nobel Prize in the year 1991. He got the Nobel Prize for his contribution towards the development of the methodology of high resolution NMR. In 1960s, he has first time used the Fourier transform technique in NMR to obtain the signal at a faster rate. And these methods that are discovered by him form the basis for the modern NMR spectroscopy. Therefore, now we are using only the pulsed Fourier transform NMR spectrometers. This pulse technique was also first introduced in NMR by Ernst. So, how a Fourier transform NMR spectrometer works? In a Fourier transform NMR spectrometer, we use a powerful short burst of energy called a pulse. That means we use a pulse. Then what is a pulse? It contains a range of frequencies. As shown in the figure, the pulse contains a range of frequencies, and this is the central frequency. Suppose you are using 60 MHz pulse. That means the central frequency will be 60 MHz. It contains frequencies above and below that. Therefore, when you use a pulse, all the different protons having different chemical shifts can be brought into resonance at a time. Therefore, it is a technique in which we can record the spectrum in less time. As I explained before, pulse will bring all the nuclei to the resonance simultaneously. And when we cut off the pulse, then the excited nuclei will come back to the ground state. That means all the protons which are excited to the beta state will come back to the alpha state. In this process, this is known as relaxation process, they will emit the radiation, that is electromagnetic radiation. And this electromagnetic radiation is plotted against the time, and this is known as the free induction decay. And the free induction decay is then used and Fourier transform to obtain the spectrum. Then how a pulse is applied? Let us consider, as shown in the diagram, that z-axis is the direction in which we are applying the stationary magnetic field. Then the pulse will be applied in the direction which is perpendicular to the z, that is y direction. Therefore, what will happen when we apply the pulse? That is known as 90-degree pulse, because the field is along the z-axis and we are applying the pulse along the y-axis, which is 90 degrees to z-axis. Therefore, when we apply this 90-degree pulse, the magnetization will tip to the x-axis. And now the protons will undergo precession in the xy plane, because they are excited by the pulse which is applied in the y direction. All these excited protons will undergo relaxation. That means they have to come back to the original state, and they will come back to the original state. In this process, as shown in the figure, they will recover back to the z-axis. Therefore, the entire magnetization will again come back to the z-axis. In this process, they will lose the energy in the form of electromagnetic radiation. That electromagnetic radiation is plotted versus the time, that is known as FID. When the pulse, as explained before, when the pulse is discontinued, the excited nuclei lose their energy and will come back to the relaxation process. And this relaxation process, they will emit the electromagnetic radiation. This is FID, a typical FID plot. And FID is considered as an exponential decaying sine wave. That means, as you see, with time, what will happen? The electromagnetic radiation emitted by the particular proton of interest will decrease exponentially. Therefore, it is like a exponential decaying sine wave. And this FID is collected and this is digitalized, and the computer will convert this FID into, this is nothing but a time domain, into a frequency domain by using the Fourier transform. The Fourier transform cannot be done manually, it can be done only by computer. Therefore, when you Fourier transform the time domain, then we get the frequency domain. This is the NMR spectrum generally we observe in our books. Therefore, actually we are getting FID, and FID is converted to the frequency domain. For example, let us consider this case for a better understanding of how FID is converted to the NMR spectrum which we generally see in our books. Let us consider this molecule ethyl alcohol. We all know, already studied in our previous classes, that the ethyl alcohol contains three types of protons. One is methyl proton, second one is methylene proton, third one is hydroxy proton. All these three protons are having different chemical shift values. The methyl protons will generate a FID like this. methylene protons will generate FAD like this, and hydroxy proton will generate FAD like this. That means different protons in a molecule will generate different FADs because they are not having the same Larmor frequency. Therefore, they are not excited at the same frequency. Therefore, the FADs will be different. And all these three FIDs will be combined and a complex FID is produced, which is then Fourier transformed to obtain the Nmr spectrum like this. So what are the advantages of this technique? By using FT-NMR, as I already explained, we can save the time, because in the FT-NMR, pulsed FT-NMR technique, we are using a pulse and we are exciting all the different types of protons in the molecule. Therefore, we can get the data or the Larmor frequencies of all the protons in a molecule with a single pulse. And also we can accumulate the data. That means first time we will apply the pulse, we will see that the nuclei will undergo relaxation, we will collect the FID. Once FID is collected, again we will apply the pulse. Like this we can carry out the process, and depending on the number of pulses, we will get the number of FIDs. All these FIDs can be combined, then we can get a very high intensity plot in the NMR. Therefore, this results in a better signal to noise ratio. As we accumulate the signal, the noise will reduce and the signal will increase. Every spectrometer will produce a noise, because a spectrometer being an electronic gadget, it will produce a noise, and the noise can be minimized provided the signal intensity is very high. And also FT-NMR is very useful in the case of nuclei like C13 and phosphorus 31 and F19. Like this, there are several nuclei which are having low gamma values. Therefore, they are less sensitive to the applied magnetic field. Let us consider this particular example. The signal noise ratio can be increased by number of scans. That means if you increase the number of scans like this, from 1 scan to 16 scans, you can observe that the intensity has been increased. In fact, it was observed that the S by N ratio, that is signal to noise ratio, is proportional to square root of N, where N represents the number of scans. Therefore, when we increase the number of scans, number of FIDs will increase. When we add all these FIDs, the noise will reduce and the signal intensity will increase. Therefore, you can see here the noise is very high, but when we increase the number of scans from 1 to 16, there is a drastic reduction in the noise and increase in the S by N ratio. Already I explained that FT-NMR plays a vital role in the case of the spectrum of the nuclei which are having low abundance and having low sensitivity, low gamma values. For example, in the C13 spectrum, when you record the spectrum after 1 scan, that means you apply the pulse and record the FID. That means you record only one FID, then see the spectrum will be like this. From this spectrum you cannot interpret anything. But when we increase the number of scans to 200, see there is a drastic change in the S by N ratio. The noise has been drastically reduced and S by N ratio has been increased. Therefore, like this, using FT-NMR spectroscopy, we can carry out the recording of the spectrum at a less time. Therefore, it is a time consuming technique, and also we can record the spectrum for the nuclei which are less sensitive to the B0 and also having low abundance. Thank you. Now I will discuss about the nuclear over Hauser effect. NOE plays a vital role in increase the intensity of the heteronuclei when they are coupled with the protons, and those protons are irradiated by the frequency using decoupler. I will explain now what is nuclear over Hauser. Before that, I am going to explain about the two types of coupling that we generally observe in the NMR spectroscopy. One is known as homonuclear coupling and second one is a heteronuclear coupling. As the name indicates, homo means same. That means if we observe the coupling between same type of nuclei like a proton and a proton or C13 and C13, it is known as homonuclear coupling. And generally in the homonuclear coupling, in the proton NMR already we have studied about the 2-bond coupling and 3-bond coupling known as geminal and vicinal coupling. The coupling constants will be in the range of 1 to 20 H. Whereas as the name indicates, hetero means different, means in the case of heteronuclear coupling, the coupling will occur between two different types of nuclei. Best example for heteronuclear coupling is the coupling occurring between a proton and C13 nucleus. The carbon is directly attached to the hydrogen, therefore this is a 1-bond coupling and the coupling constant will be very high in the range of 100 to 200 H. The coupling may occur between the hydrogen and carbon when they are separated by 2 or 3 bonds. This is a 2-bond coupling, this is a 3-bond coupling and the coupling constant values are very low in the range of 2 to 10 H. Now we will concentrate more on the heteronuclear coupling to explain the NO in a better way. With C13 NMR, the splitting occurs from the hydrogens because hydrogens are directly attached to the carbon atom. It is very important to note that the signals due to the C13 nuclei will split not only due to the directly attached hydrogens but also due to the nearby hydrogens. Then the spectra of C13 are commonly proton coupled spectra. As I already explained, the hydrogens which are directly linked to the C13 and also the nearby hydrogens will split the NMR C13 NMR signals. Therefore, we obtain a complex spectrum. There will be number of multiplets which will overlap with one another. Therefore, it is very difficult to interpret a completely coupled proton spectra. We cannot get any meaningful information about how many carbons are there, how the carbons are coupling with the nearby and the directly attached hydrogens. Therefore, what we will do is, in most of the cases, whenever we record the C13 NMR spectrum, we will decouple the proton. How we can carry out the decoupling? Decoupling process is carried out by using a second frequency known as a second frequency generator known as decoupler. Therefore, in the case of decoupling experiment, we have to use two frequencies. One frequency to excite the C13 nuclei and the second frequency to saturate all the protons. Therefore, they cannot undergo coupling with the carbon atoms. Therefore, what we will do is, in proton decoupling, we will remove the coupling interactions. In the proton decoupling, we will remove the coupling interaction between the C13 nucleus or nuclei and the protons. So, therefore, in a proton decoupled spectrum, we will get only the singlets which are due to the different types of carbon atoms present in the molecule based on the chemical environment and the delta values. Therefore, how a decoupler works? When we start the decoupler, it will generate a tunable frequency so that two things will happen. One is decoupling occurs, second one is saturation. We have to understand these two terms. One is decoupling, second one is saturation. Let us consider A is the nucleus of interest and X is the nucleus which is coupling with the A. And when we switch on the decoupler, when we radiate the X nucleus with using the tunable frequency, then what will happen? All the X nuclei will undergo saturation. That means the number of X nuclei in the alpha state and beta state will become equal. When they get saturated, then the neighboring nucleus cannot distinguish the X nuclei in the alpha state and beta state. That means there will be a rapid transition of X nuclei between X and between alpha state and beta state. Therefore, the nearby nucleus cannot distinguish X in the alpha state or in the beta state, because between these alpha state and beta state, X is rapidly undergoing the transition. Therefore, A can only observe the average spin state of the X. Therefore, there will be no coupling between the A and X nucleus. Therefore, you will see only singlet. Previous in this case, if there is one X, then we are getting a doublet because A is coupling with the X. But when X is saturated, that is decoupling, then the other thing is also happening. Because of the saturation of the X nuclei, the alpha and beta population will become same. Therefore, the nuclei in the alpha state will not undergo a transition to the beta state. Therefore, there will be no signal due to the X. Therefore, when you switch on the decoupler, the two things are happening. One is X is decoupled with the A, or in other words we can say A is decoupled with the X, and also there is no signal due to X. This is possible only when A is coupled directly with the X or when A is near to the X. And there is other type of coupling that is known as off resonance decoupling. When we completely decouple the hydrogen atoms which are attached to the carbon atoms, then we are missing the information regarding the hydrogens which are attached to the carbon. For example, we cannot distinguish whether a particular carbon is methyl carbon or methylene carbon or methane carbon when we completely decouple the proton information. Therefore, there is another method that is known as off resonance decoupling. In off resonance decoupling, we will retain the coupling of the carbon nucleus with the directly attached hydrogens, but we will eliminate the coupling between the C13 and the nearby hydrogens which are not directly attached to the hydrogen atom. Therefore, when we use off resonance decoupling, then for CH we will get a quartet, for CH2 that is methylene carbon we will get a triplet, and for CH we will get a doublet. Then what is the difference between a completely decoupled and off resonance decoupled? In the case of completely decoupled spectrum, we send the frequency using decoupling in such a way that it will cover all the frequencies of the carbon atoms. Whereas in the case of off resonance decoupling, we will send the frequency which does not match exactly with the resonance frequencies of the protons, but it will be above or below their frequencies. That means it will contain all the frequencies, but the frequencies will be below or above the frequencies landmark frequencies of the protons. Therefore, they will not undergo complete saturation. Therefore, now we will discuss about the NOE. What will happen when proton is decoupled? It was observed that when the protons are decoupled with when the protons which are attached to the hydrogens are decoupled, then because of the decoupling, there is an increase in the intensity of the signal due to the carbon nucleus. That means we are having a carbon nucleus which is undergoing the coupling with the hydrogen nucleus. When we decouple this X nucleus by using the decoupler frequency, then what is happening is the coupling information is missing, and also at the same time it was observed that the signal due to the carbon will increase. That means C13 nucleus will increase, and this enhancement was known as nuclear Weyerhaeuser enhancement, and this effect is known as NOE effect or nuclear Weyerhaeuser effect. You can understand in a better way by looking at these two spectrums of 2-butanol. One spectrum is recorded when it is off resonance decoupled, and second one when it is proton decoupled. In the case of off resonance decoupled, you can see that for these different protons there is a coupling between carbon and the hydrogen. That means for methyl carbon we are getting a quartet, that means 4 lines, but the methyl carbon will not undergo the coupling with the protons in the methylene group hydrogens, because we are using the off resonance, therefore decoupling. Therefore, it can only the C13 in the methyl group can only couple with the attached hydrogens, but it cannot couple with the hydrogens in the nearby methylene group. When we completely decouple, then we will get only singlets for methyl, methylene, and different types of other protons, other C13 nucleus. So, as I explained before, there is a increase in the intensity of the one spin. When we irradiate the other spin which is coupling with this by using a decoupling frequency, and this NOE concept was first introduced by Hauser. The NOE can be two types, can be homonuclear or heteronuclear. NOE is a homonuclear NOE when it is operating between the identical nuclei. That means if a proton is coupled with other proton and there is an enhancement in the signal when one proton is decoupled, then it is known as homonuclear NOE. When the NOE is operating between different nuclei, one is C13 and second one is proton. When we decouple the proton, there will be enhancement in the intensity of the C13 nucleus. The vice versa also applies. That means when we decouple C13, then there is a increase in the intensity of the proton. Theoretically, we can calculate how much enhancement we can obtain by the NOE. The NOE maximum is equal to 1/2 times the gamma irradiated by gamma observed. Then what is the gamma irradiated? It is a gyromagnetic ratio or magnetogyric ratio of the irradiated nucleus, and the gamma observed is a magnetogyric ratio of the observed nucleus. In the case of C13 and 1A system, you can see if you substitute, for example, if you substitute the gamma values, gamma of hydrogen is 4 times the gamma of the C13. Therefore, gamma irradiated by gamma observed will be 4/2. Therefore, it will be that means you can get 200% enhancement in the signal when the proton attached to the C13 nucleus is decoupled. NOE can be positive or negative. If both the gamma values as given in the formula are positive, then NOE will be positive. If one of the gamma values is negative, for example, the N15 nucleus is having negative gamma value. Therefore, even though 1H is having positive gamma value, if one of the gamma value is negative, then NOE will be negative. That means when we decouple the proton, then the signal will due to N15 will intensity of the signal will decrease rather than enhancement in the signal, as observed in the case of C13. Therefore, it was observed that NOE effect, or we can say nuclear over Hauser effect, will increase, will be more pronounced when the carbons are directly attached to the, when the hydrogens are directly attached to the carbon. Therefore, it is more pronounced in the case of methyl group, because in this group the carbon is attached directly to 3 hydrogens. In the case of methylene, carbon is directly attached to only 2 hydrogens. Therefore, the effect will be less pronounced. And it is important to note that the NOE operates not through bonds but through space. There is one basic difference between the coupling we already studied and the NOE. In the case of NOE, there is a dipole-dipole interaction that occurs through the space. That means if the two nuclei are closer, at a distance closer, and they are at a distance of nearly 3 to 5 angstrom units or 3 to 6 angstrom units, then they can undergo coupling through space. Therefore, one dipole, the nucleus being a dipole, can interact with the other nucleus being a other nucleus which is also dipole. Therefore, this dipole-dipole interaction can occur through space, provided they are separated by distance of 3 to 5 or 3 to 6 angstrom units. Whereas the general coupling, which already we studied in our class, which involves the bonds between the two nuclei, and therefore NOE can be given by, or NOE depends on the function of 1 by r cube, where r is the radial distance between the two nuclei. One is C13 and another one is proton. Therefore, as the radial distance increases, then NOE decreases at a faster rate. Therefore, how we can explain NOE in a theoretical manner? NOE is an example for cross polarization. What is happening in NOE is, when we are irradiating one of the nuclei, then there is a change in the population of the spin states. That means let us consider C13 and 1H system. C13 1H system. we are decoupling the hydrogens or protons by using the decoupling frequency. When we decouple the protons, then when we supply the energy to decouple the protons, then there is a polarization in the spin states. That means, already I explained about this, the alpha state population and beta state population will become equal, therefore they will get saturated. According to Boltzmann distribution at room temperature, the alpha state should have more population and beta state should have less population. But when we are irradiating the protons using the decoupling frequency, then what is happening is, in the case of protons, the population will become same for the alpha state and beta state. Therefore, the nearby C13 will sense this change in the polarization. Therefore, there will be a change in the polarization, the population of the C13 nuclei in the two spin states. Therefore, this is known as cross polarization. The change in the population of the spin states in the one nucleus will bring a change in the population of the spin states in the other nucleus. Therefore, as I already explained, the predicted intensity will be 1 plus NOE maximum. Therefore, when you substitute the values of the that is gamma values for the irradiated nucleus and C13, you can see that there is a enhancement by 200%. Then what are the important applications of NOE? As I already explained, NOE can operate in both the directions. That means we can increase the intensity of C13 nucleus by decoupling proton, or we can enhance the intensity of proton by decoupling the C13 nucleus. But NOE is more useful in the case of C13 nuclei which are decoupled with the protons. That means when you decouple a proton which is coupled to the C13 spectrum, then there will be the enhancement in the intensity of the C13 spectral lines. Why we are more interested in heteronuclear NOE effect? Because the C13 nucleus is having low abundance and low gamma value. Therefore, generally the intensity of the line, spectral line or NMR peak due to C13 nucleus is very less. Therefore, when we decouple the proton which is attached to C13, there will be enhancement in the C13 peak and we can observe them very easily in the spectrum. Then I will discuss about two applications of NOE. One in the case of heteronuclear coupling, another in the case of homonuclear coupling. In this particular molecule that is known as DMF, this is a C13 spectrum, and in this DMF molecule there are two types of methyl groups. One is known as anti, the second one is as syn, because this particular CN single bond is having partial double bond character, and this syn methyl will be having more delta value compared to the anti methyl group. Therefore, it is more downfielded when compared to this. Therefore, we are getting the value of syn like here, and the corresponding chemical sheet for the syn anti will be like this. When we irradiate, here what is happening is this aldehydic hydrogen is undergoing the coupling with the anti with the C13 in the anti methyl group and also with the C13 in the syn methyl group, and this is occurring through space. Therefore, when we decouple this particular proton, then there will be a NOE effect on both these C13 that is present in that are present in syn and also in the anti methyl groups. But it was observed that this NOE effect will be more pronounced in the case of C13 peak compared to the C13 in the anti group, because this proton is in the close vicinity to this proton is close, and this proton is in the close vicinity to the syn methyl group compared to anti. The distance here is more, and the distance here is this R value is here low when compared to the R value here. Therefore, there will be enhanced intensity in the peak due to the carbon in the syn methyl group compared to the carbon in the C13 peak in the anti methyl group. This is a best example for a NOE effect which we observe in the decoupling experiment. And second one is when there is a proton-proton coupling. The best example is isovanilline. In isovanilline, this particular proton designated as HA is coupling with the methoxy group. That means this carbon, the hydrogens in the methyl group or methoxy group will couple with this particular HA. This occurs through space. There is NO interaction through space, and this HA is having a doublet. As you can see here, there is a doublet. This doublet is due to the coupling of HA with HB. It is very important to note that the HA protons will not couple directly with the protons in the methox group. They will undergo direct coupling, that is through bond coupling with HB only. Since HB is only one, therefore based on the formula HA is a doublet. And when we decouple this HA, then it was observed that when we decouple this methyl protons, it was observed that there is increase in the intensity of the peak due to HA, and this increased intensity is nearly 30%. In the case of proton-proton system, when we decouple one proton, then the signal due to other proton can enhance only by 50%. Therefore, when we decouple this proton, these protons, then there is increase in the intensity of the signal due to this proton, HA proton, by 30%. Therefore, in this particular topic, I have discussed about what is NOE, what are the benefits of NOE. Now I will discuss about the Epr spectroscopy. In my previous presentation, I already discussed about the basic concepts in Epr spectroscopy. The comparison, I have made a comparison between the Nmr spectroscopy and Epr spectroscopy. Briefly, I will discuss about the basics of Epr spectroscopy. I will concentrate more on the applications of Epr spectroscopy. It was discovered by Jaworski in the year 1944, and we already know that Epr spectroscopy is an important spectroscopy technique for the detection of the unpaired electron. The unpaired electron, which is present in an organic molecule known as organic radical or in a metal ion in a complex, can be detected. Therefore, Epr plays a vital role in the bioinorganic chemistry and in the biology. And we can detect all these type of paramagnetic species using the Epr. And Epr is also known as electron spin resonance spectroscopy, that is ESR. The first derivative point parameters, one is chemical shift and is coupling constant. The analogous parameter describes the interaction between the electron and the applied magnetic field B0, and G values are generally in the range of 2.0023 for a free electron, and G values will deviate from this particular value depending on the environment. That means G values will depend on the spin orbit interaction. Therefore, in the case of small organic radicals, G value will be in the range of 2, whereas for the species which are having high atomic number, the G value will generally deviate from the value of 2.0023. Therefore, we will go to the basic theory about the G value. When let us consider an electron which is free and free in the space. Therefore, this electron, we know that electron is having spin motion. Therefore, as shown in the figure, it will undergo a spin motion. When we put this electron in a magnetic field B0, then it will be having two orientations. One is the beta orientation, second one is alpha orientation. One is beta spin state and second one is alpha spin state. The beta spin state has given the value of -half, and alpha spin state is characterized by +half. And this is having energy of this minus G beta into B0 by 2, and this is having energy of this energy of this. Therefore, the gap between these two, the energy gap is given by G beta and B0. Therefore, the energy of the electron in energy level is given by the product of mu and B naught. Mu is the magnetic moment, because it is undergoing a spin motion. Whenever a charge undergoes a motion, then there will be a magnetic field generated, and the magnetic field associated with that particular motion is regenerated by the magnetic moment mu. Therefore, how we can calculate the G value? As explained in the previous slide, delta E gives the energy between the two spin states, and this delta E can be equated to h nu, which is equal to G into beta into B naught. Here beta is a Bohr Magneton value for the electron. When we substitute all the values, we can arrive at the value of 2.0023. That means for the free electron in the space, there is no interaction with the with other particles, then the G value will be like this. But the G, we cannot take the electron as a free particle. It should be present in a molecule. Whenever the electron is present in a particular molecule, then it will be having the orbital motion in relation to the spin motion, because the electron will be present in orbit and it will revolve around the nucleus as shown here in a particular orbit. Therefore, there is orbital motion in relation to the spin motion. Therefore, there will be orbital angular momentum and the spin angular momentum. Therefore, now the orbital angular momentum also will contribute to the mu value. Therefore, the total but it is observed that whenever electron is present in the ground state, then the L value can be equated to 0. Therefore, in such a case, the mu should be equal to Ge into S bar. But it was observed that there will be always a interaction between the ground state and excited states. That means there will be spin orbit coupling. Therefore, instead of L bar, we can write the mu proportional to GES bar plus spin orbit coupling contribution. That means in the case of molecules, one orbital will interact with the other orbital. That means electrons present in one orbital will interact with the electrons present in other orbital. Therefore, and also there is an interaction between the spin motion and orbital motion. Because of these interactions, there will be a change in the G value. Therefore, the spin orbit contribution can be equated to or can be proportional to S bar. Therefore, the mu will be proportional to G into S bar. That means instead of G, now we are writing G. Therefore, the G value will in turn depend on the spin orbit coupling contribution. Therefore, one thing we have to remember as long as G is concerned is that the G value of an electron in a molecule will depend on the spin orbit contribution value. The G value is deviating from the G value of the free electron Ge due to this spin orbit contribution. And it was also observed that in the case of metal complexes, the G value varies substantially because the G value will depend on the spin orbit interaction. Therefore, in the case of metal complexes, the Epr spectroscopy is more interesting because the G values will give information regarding the electronic structure, whether the electron is present in dx square y square orbital or dz square orbital. Based on the electronic structure, we can arrive at the geometrical shape of the particular complex. And the second important parameter is hyperfine interaction. The hyperfine interaction is indicated by A value. The interaction between the electron and the nucleus, nearby nucleus, is given by A. And because of the interaction between the electron and the nearby nucleus, there will be splitting of the lines due to the electron and is given by the formula 2Na plus 1. Therefore, how this splitting occurs? Let us consider this is a free electron which is having present in the B0 having two spin states minus half and plus half. When this particular electron which is present in alpha state or beta state is interacting with the or is coupled with the nucleus which is nearby, then the splitting of the states will be like this. That is, for the beta state there will be two states, alpha beta, and also for alpha state also there will be two spin states, beta and alpha. That means there will be a splitting of the nuclear spins and also electronic spins. This is the splitting of the electronic spins in the B0 and this is the splitting of the nuclear spins. That means this is known as electron G-man, this is known as nuclear G-man. electron is undergoing the electronic spin states are undergoing splitting in the presence of magnetic field. Like that, magnetic spin also will undergo splitting. For electron there are two spin states, alpha, beta. Like that, for proton also there are two spin states, but the lower spin state in the case of electron is beta, whereas in the case of proton is alpha. Because of these interactions, now we will get two lines, and the selection rule here is, in the case of electron spin states, delta ms should be equal to plus or minus 1, whereas in the case of nuclear spin states it should be equal to plus or minus 0. Therefore, only there will be, based on the selection rules, there will be only two transitions, and there will be two transitions between beta alpha and alpha alpha, and other transition between beta beta and alpha beta. If there are two protons or two nuclei having a spin of 1/2 interacting with the electron, then the splitting will be like this. We are having two protons. The two protons may be present in the plus half state, that is the total value will be 1. The two protons may be present in the minus beta state, that is minus half state, then the total value will be minus 1, or one may be present in the alpha, one may be present in beta. They both protons are present in the alpha states, the value will be plus 1, both in beta state minus 1, one is alpha, one is beta, it will be 0. Therefore, based on the selection rules, now the three lines are possible. That means if the electron undergoes coupling with the two protons, then based on the formula there will be three lines in the spectrum. Based on the number of lines, based on the number of nuclei which are coupling with the electron, we will see different lines in the spectrum. Therefore, this is the based on the basic equation for EPR. We can write for each electron the electron G-man energy factors. These are the electron. This corresponds to electron G-man, and this corresponds to nuclear G-man, and this corresponds to the hyperfine energy term. Therefore, this is a Hamiltonian. That means total energy of the electron in the this state and this state. Like this, we can write the Hamiltonian, the total energy for this state and this state, based on the formulas in the previous slide. And based on the transitions, we can arrive at the difference in the total energies of these two peaks, and this value will be equal to A. That means, like this, we can theoretically calculate the A value. And now I will discuss about the EPR spectrums of some other radicals. For example, hydrogen atom is a best example, because hydrogen atom contains only one electron and one nucleus. Therefore, there will be two lines, and the coupling constant value will be 507 Gauss. In the case of methyl radical, the radical which is present on the carbon atom will couple with the three protons. Therefore, there will be four lines in the ratio of 1:3:3:1. In the case of benzoquinone radical, there are four hydrogen atoms with which the radical will combine. Therefore, based on the formula n+1, we will have 5 lines in the spectrum. In the case of benzene radical, there will be 6 protons or hydrogen atoms which are coupling with the electron of interest, and there will be, based on the formula 6+1 = 7 lines in the spectrum. Now we will discuss briefly about the anisotropy in the G and A values. The G values will not be uniform when we take the sample in the solid state. Generally, the EPR spectra are recorded in the solid state. In the solid state, all the molecules are locked in their particular positions. They cannot move freely. Therefore, based on the direction in which we are applying the B0, the G will be having 3 values. That means G will have 3 components along the 3 Cartesian coordinates, known as Gx, Gy and Gz. When all the 3 values are same, the spectrum will be isotropic. For example, in the case of octahedral complexes, all the G values will be same. Therefore, we will have the isotropic spectrum. When the one G value differs from the other 2, then it is known as axial spectrum. It is observed in the case of square planar complexes. First, there are different equations to explain all these factors. Just I will consider one equation for the axial spectra. Let us consider z-axis is the axis in which we are applying the magnetic field, and the angle between the z-axis and the field is theta, and the angle between this x-axis and the component of B and Y is equal to phi. When theta value is equal to 0, when we substitute theta equal to 0 in that particular equation, we know that sin theta is equal to 0, therefore cos theta will be equal to 1, therefore G axial 0 will be equal to G Z. That means when generally we consider that the Z axis will be coaxial with the applied field, and therefore the GZ will be coaxial with the B, whereas Gx and Gy are parallel to the GZ and the magnetic field. And these are the different types of spectra we obtain when depending on the G values. When all the G values are same, we will get only one peak. When in the case of axial, when G parallel is greater than Gx and G parallel is greater than Gx and G double prime, this will be like this. And this other case of axial spectrum, and when all the three G values are different, we will get a spectrum like this. And in the case of gaseous metal ion, the G value can be calculated like this. But generally the metal ions are studied in the form of complexes. Therefore, when you take a complex, you have to record the spectrum either in the solution state or in the solid state. When we record, generally most of the time we will record the spectrum in the solid state. Therefore, there will be three G values along the three directions, and a given Epr spectrum contains different G values based on the electronic environment. Therefore, G value will deviate from the G, and it will depend on the spin orbit interaction. Therefore, there is easy way to determine how many G values a particular metal ion will be electron in a particular metal ion is having based on the electronic environment. This is the formula to calculate that. Here K is a constant which gives the extent of orbital mixing, how one orbital is mixing with the other orbital, and the orbital interactions can be determined by K, and the spin orbit coupling constant is given by lambda, where E0 is energy of the ground state, En is energy of the excited state. And we can make use of this magic pentagon to arrive at the value of K. Therefore, this magic pentagon is having three levels based on the M values. You know that d orbital is having a L value of 2, therefore M values can be plus 2, plus 1, 0 or minus 1 or minus 2. Therefore, there are three levels, and we have to understand one thing is that whenever the dx square y square orbital interacts with the xy orbital, then the K value has to be taken as 8. When dx square y square orbital interacts with the yz, the value will be equal to 2. That means when we are applying the field along the z direction, then the spin orbit coupling will occur along the x and y axis. Therefore, when we are considering the interaction of the magnetic field with the G in the z direction, we have to consider the coupling between the dx square and the dxy. Therefore, we have to take the K value as 8. Let us consider this particular complex, that is a square planar complex. Best example is CuCl4 2 minus, that means tetrachloro copper 2 complex. In this particular complex, that is tetrachloro cuprate complex. Okay, in this, but this is having D9 configuration, and we have studied in coordination chemistry that there will be one electron in the dx square y square orbital. Now this orbital will be the ground state orbital, and we can calculate the G values. When we assume that z axis is parallel to the B0, therefore GZ is G parallel, and x and y are perpendicular to the B0. Therefore, x and y axis are considered as G perpendicular axis. Now, when we are considering the spin orbit coupling along the z direction, we have to consider the interaction between dx square y square orbital and dxy orbital. Therefore, the K value is taken as 8. When we are considering the interaction along the x axis or y axis, then we have to consider the coupling between dx square y square and dxz, or dx square y square and dxy. In such a case, the value will be 2. Therefore, based on this calculation, we can find that the G parallel values will be greater than G perpendicular, which are in turn greater than GE. Therefore, for this particular complex, we will get the spectrum like this. You can see that there are 2 G values in the square planar complexes. That means the axial spectrum generally will contain 2 G values. The G parallel may be greater than G perpendicular, or G parallel may be less than the G perpendicular. perpendicular, and each G value split into 4 lines, because we know that here the nucleus is copper, which is having a I value of 3/2, and there is 1 electron. Therefore, based on the formula, there will be 4 lines for each of the G value, and these are given by, and the splitting is given by A parallel, and the A parallel will be more here and less here. In fact, in this also there will be 4 lines, but this since A perpendicular values are very less and compared to A parallel, the spectrum is generally shown like this. Thank you.
Syed Wajihat Hussain, lecturer in biochemistry, SRR and CVR Government Degree College, Vijayawada. Today we are going to discuss about the structure of nephron, the functions of nephron and the mechanism of urine formation in detail. So coming to so what are the objectives of today's lecture? In this lecture, we are going to understand the complete structure of nephron, and we are going to understand how the nephrons work, what are the functions of the nephron and how do they work, and we will also gain knowledge about the process of urine formation, and we will understand the clinical importance of this topic. So these are the objectives of today's lecture. And now coming to the structure of nephron. So nephrons are the structural and functional units of the kidney. Coming to, first we will see how what is the organization of kidney, structure of kidney, then we will go into the structure of nephrons. So kidneys are bean-shaped organs. So you can observe here, kidneys are bean-shaped paired organs. They are located in the peritoneal cavity, and these are the chief excretory organs, and kidneys are usually they are existing from 13th, you can see the 12, they are paired organs and they are existing in the peritoneal cavity. So coming to the length and width of the kidneys are usually 10 to 12 centimeters in length and 5 to 6 centimeters in width. They have 4 to 5 centimeters in thickness. So that is the usual measurements of the kidney. And coming to the weight of the kidneys are around 150 grams in males and little bit lesser, that is 135 grams in females. So usually right kidney is a little bit smaller than the left kidney. These kidneys which are existing in the peritoneal cavity, the paired organs, they are, if you observe the cross section of the kidney, so in the cross section of the kidney, here in the diagram you can see, so you have in the cross section of the kidney, there is a peripheral dark region. So this region is called as cortex, and you also have the lighter region which is called as medulla. So coming in the kidney structure, you can observe a deep notch here. Through this notch, usually the blood vessels, that is veins, arteries, enter into the kidney, and ureters passes out through the kidney. Then nerves also enters through this deep notch. This is called as hilus. Then this is the basic structure of the kidney. So again, once again, I'll revise. Kidneys are bean-shaped organs. These are the paired organs which are chief excretory organs. They are located in the peritoneal cavity, and each kidney measures about 10 to 12 centimeters in length and 5 to 6 centimeters in diameter, and you have the thickness of 3 to 4 centimeters of thickness is there. And each kidney, coming to the weight of the kidney, each kidney weighs about 150 grams in males and little bit lesser, 135 grams in females. And usually the right kidney is smaller than the left kidney. And you can also see there is the deep notch here in the medial region. So where you have the hilus, through which usually the blood vessels, there is arteries and veins enters into the kidney, and your ureters come out of the kidney. Nerves also enters through this region. So you have a peripheral dark region which is called as the cortex, and lighter region, this is called as the medulla. Right. So coming to our today's main concept, that is the structure of the nephron. Nephrons are the structural and functional units of the kidney. So if you can see the structure of the nephrons, histologically you have two different types of nephrons. So what is the arrangement of the nephron, and if you observe the histology, so you can see there are two varieties of nephrons. The first one are suprarenal nephrons. Those are which are arranged in the top. They are called as superficial nephrons. The second one are juxtamedullary nephrons. So you can see in this diagram, so the topper, so in the cortex region, the top of the cortex region, you have the superficial nephrons. Superficial nephrons, these are the nephrons which are fully functional. They are the fully functional nephrons. In all conditions they are working, means in all conditions they are under the work. So these are the superficial nephrons. They are around 85% of the total nephrons are superficial nephrons. Then you have the juxtamedullary nephrons. These occupy 1/3 of the cortex. Superficial nephrons occupy 2/3 of the cortex, and they will occupy 1/3 of the cortex. So in this 1/3 of the cortex, you have the juxtamedullary nephrons. These juxtamedullary nephrons are longer, they are large, they are having large tubules compared to the superficial nephrons. Superficial nephrons are having smaller tubules, and they are existing 2/3 region of the cortex, and juxtamedullary are 1/3 region of the cortex. They are around 85%. The remaining 15% are juxtamedullary. So 85% are the superficial nephrons. Superficial nephrons are fully functional, and juxtamedullary nephrons work only in the stress conditions. So this is the arrangement of the nephrons in the cortex and medulla. Then if you observe the structure of the nephrons, coming to, we'll see in deep what is the structure of the nephron. So nephrons are having the 6 different types of structures. We can divide the entire structure of the nephron into 6 different parts. The first part is called as a renal or Malpighian corpuscle. So the first one is renal or Malpighian corpuscle. The second one is proximal convoluted tube. The third one is descending loop of Henle. Then you have ascending loop of Henle, in which again you have thin ascending loop of Henle, thick ascending loop of Henle, and you have distal convoluted tubules and collecting duct. So we will see in the structure of nephron the entire parts. So this is the renal corpuscle, or this renal corpuscle again opens into the this proximal convoluted tube. Then you have the Henle's loop. This is called Henle's loop. In Henle's loop you have, this is the descending Henle's loop, and this is the ascending Henle's loop. In the ascending Henle's loop again you have thin ascending Henle's loop, and this is the thick ascending Henle's loop. Then you have the distal convoluted tubule. Then this is the collecting tubule. So this is the entire structure of the nephron. So these nephrons usually they are existing 1 to 1.2 million in each kidney. That means completely the number of nephrons existing in your 2 kidneys are around 2 to 2.4 million nephrons are working. So these are the microstructures which are existing in the kidney and carry out all the functions of the kidney, that is homeostasis and the excretory functions. So kidneys are the important organs which are involved in the homeostasis, and they are also the chief excretory organs. So all the functions of the kidney are carried out by the structures called nephrons. So nephrons are, what is the number of nephrons? Nephrons are around 1 to 1.2 million in each kidney. That means 2 kidneys are having 2 to 2.4 millions of nephrons. So this is the basic microstructure of the nephron. Nephron is having, this is renal corpuscle, and you have proximal convoluted tube, then you have Henle's loop, then you have distal convoluted tube, and this is the collecting duct. So we will see each part and what is the function of the each part in detail. Okay, so first the first structure that we saw is the renal or Malpighian corpuscle. This is the Malpighian corpuscle, and this is around 200 microns in diameter. This structure we have observed here. So this is the Malpighian corpuscle, and which is of 200 microns in diameter, and it is composed of 2 structures, that is the glomerulus and Bowman's capsule. So this is in the middle you have this is the glomerulus, and surrounding this you have a cap-like structure that is called as Bowman's capsule. So you can observe these 2 structures in the Malpighian corpuscle. So for coming to the glomerulus, so what is glomerulus? Glomerulus is a small, this is the tuft of capillaries. So when usually see in the structure, this is the efferent arteriole and this is the efferent arteriole. So you have seen here that this Malpighian corpuscle, in this efferent arteriole enters and it supplies blood to the glomerulus, so this Malpighian corpuscle, and this blood again it is passed through the efferent arteriole, which is converted as vasa recta. Then so if you observe in the 2 structures, that is the glomerulus and the Bowman's capsule. So what is glomerulus? Glomerulus is a tuft of capillaries. It's a tuft of capillaries which is formed from the efferent arteriole. So this efferent arteriole, this is the efferent arteriole, it brings the blood from the from all the parts of the body to the this glomerulus. So this afferent arteriole is again divided into some around 50 loops of capillaries which forms the glomerular tuft. So this glomerular tuft is the bunch of capillaries. So this is the structure, and which again here the capillaries are converted again into efferent arteriole which takes the blood to the this region that is called as vasa recta, to blood vessels called vasa recta. Then see, if you observe in the glomerulus, you have 2 different types of cells. The first one are called as endothelial cells, the second one are called mesangial cells or mesenchymal cells. So here you can see you have this inside the blood vessel wall inside is covered by endothelial cells. So here you can see this is the endothelial cells, and you have endothelial cells inside the blood vessel. Then in between you can see this blue color cells which are called as mesangial or mesenchymal cells. These mesenchymal cells supports the capillaries. See, we already said that the efferent arteriole is divided into a bunch of capillaries, capillary loops. Around 50 capillary loops forms the glomerular tuft. So in the glomerular tuft, each capillary is again inside, it is lined by endothelial cells, and these are the endothelial cells. In between the capillaries you have the mesangial cells or mesenchymal cells. These mesenchymal cells supports these capillaries, and they are also having the property of contraction. So they are also contractile properties also existing to the mesenchymal cells. And mesenchymal cells, they are not only supports the capillaries, and they will maintain the volume of the capillaries also by contraction, and they also produces extracellular matrix inside this Bowman's capsule. There is Bowman's capsule. So then you have capillaries. Capillaries are underlined by the endothelial cells, which are having very important role in filtration of the blood. So this is the basic structure of this tuft of capillaries called glomerulus. Then again we can see the Bowman's capsule. So the tuft of capillaries are these are existing in a cup shaped structure which is called as a Bowman's capsule. So this Bowman's capsule, it again contains two different types of cells. So you can see the Bowman's capsule. So usually the Bowman's capsule is the dilated end of the nephron, and it consists of two layers. One is Proton. So you have two different cells here. One is the parietal layer and the visceral layer. So in the structure you can see, so this is the parietal layer, and this one here you can see the green color here, so which surrounds these capillaries, that is called as the visceral layer. So in the parietal layer you have the squamous epithelium, and which is again converted here it is existing as the this is the squamous, and this is the cuboidal epithelium, which is again converted gradually, it is converted into proximal convoluted tube. So here in the this is the second, that is the Bowman's capsule. In the Bowman's second part of this Malpighian corpuscle, the first one is the glomerulus, second one is the Bowman's capsule. In the Bowman's capsule you have two different types of cells. So what are those? You have the parietal epithelial layer, and you have visceral epithelial layer. So parietal epithelial layer is having squamous cells and cuboidal cells which are gradually existing into proximal convoluted tube. Then you have this visceral epithelial layer, okay, which surrounds these capillaries. So the visceral epithelial layer which is surrounding the capillaries is extensively modified, and the cells are called as, the visceral epithelial cells are converted as podocytes. So you can see the diagram of podocytes here. So these are the podocytes. See, this visceral layer is converted into podocytes. Podocytes are the cells, visceral epithelial cells. They are modified structure, modified cells, and these cells are having pedicels in their structure. Means their membrane is their cell membrane is elongated to form this type of structures. So they are called as pedicels, or they are primary food processes. These are the primary food processes. So the cell is existing. You can see the structure of the cell. What animal is you remind by seeing this cell? You can see this is the structure is like octopus. The podocytes are octopus like cells. They structure similar to the octopus, and they usually exist on the they covers the top of these blood vessels, capillaries, and they are having the primary processes and secondary process, primary food process and secondary food process. The primary food process and secondary food process, so this is the podocyte, and it is having the primary and secondary food process. These food processes interdigitate among themselves to form a structure called slit diaphragm. It is called as the slit diaphragm. So now once again we will see the structure of this complete Malpighian corpuscle. Malpighian corpuscle or renal corpuscle, into which the blood is supplied by the afferent arteriole and blood is taken away by the efferent arteriole. Coming to the afferent arteriole, which brings the blood to the corpuscle, this is again divided into a tuft of capillaries. This tuft of capillaries is called as the it is called as glomerulus. Glomerulus is having many capillary loops. These capillary loops are having two different types of cells which are very important. The capillary, inside the capillaries you have the endothelial cells and in between the capillaries you have the mesangial cells. Then this glomerulus is covered by, which is existing in the Bowman's capsule. Bowman's capsule is again having two different types of epithelial layers. One is the parietal epithelial layer, the second one is the visceral epithelial layer. Parietal epithelial layer is squamous and cuboidal, and this visceral epithelial layer in which you have the epithelial cells which are converted as podocytes. Podocytes are the structures which are podocytes are the octopus like cells which are terminally differentiated cells. They are terminally differentiated cells which are having the primary food processes and secondary food process which are interdigitated. They are existing around the capillaries to form the structure called slit diaphragm. So this is the basic structure of the Malpighian corpuscle. So in the Malpighian corpuscle, the process of glomerular filtration is carried out. So what is the glomerular filtration? So blood comes when the blood enters through the efferent arteriole. So here the blood gets filtered and all the blood cells and larger proteins which cannot be filtered, and only smaller particles such as ions, different types of ions, and smaller organic molecules which are easily filtered through this glomerular filtration unit. So we will observe the glomerular filtration unit where the primary filtration process of blood is carried out in the first step of urine formation. So you have a glomerular filtration barrier. So already we have observed that in the Bowman's capsule. So this is the glomerulus, and inside the glomerulus, if you observe, you can observe the three different layers. The filtration unit consists of three different layers. So the first one is the capillaries inside. I already told you that inside the capillaries you have the endothelial membrane. Endothelial. So this is the endothelial layer. So in the endothelium you have special type of cells. In the endothelial cells, you have a special type of cells which are having many pores. They are called as fenestrae. The pored structures inside the endothelial layer are called as fenestrae. These are the special type of endothelial cells. Nowhere in the body they exist. They are existing only in the kidney capillaries. In the kidney capillaries which are formed as the glomerulus, you can observe this type of endothelial cells which are having small pores. They are called as fenestrae. So through these fenestrae, which are around 50 to 100 nanometers in diameter. So through these fenestrae, the filtration process is carried out. Then you have the second structure that is called as the basement membrane. So capillaries are existing. Capillaries are surrounded by this basement membrane. So basement membrane is the layer in which you have collagen. So the basement membrane is made up of collagen 4. Collagen 4 protein is existing in the basement membrane, which is crisscrossed to form network-like structure, which is also involved in the filtration process. So see here, when the blood enters into the capillaries, this is the capillary inside. So when the blood enters into the capillaries, it gets filtered. In the filtration process, the cells, all the blood cells, white blood cells, RBC, WBC and platelets all remains outside, and through the fenestrae only some proteins smaller proteins can be passed, which are having less than 50 nanometers in diameter. So when they enter, but here another problem. So when the proteins try to enter, so in this basement membrane, you have negatively charged structures which are called as heparon sulfate. In the basement membrane, you have heparon sulfate, which are negatively charged structures. They does not allow the negatively charged proteins to come in because of charge repulsion. So this is another barrier which does not allows because of the charge. Usually proteins are having negative charge, and that does not allow due to the charge repulsion. Then these octopus cells, which are podocytes, which are interdigitating food process from the slit diaphragm. So this slit, through this slit diaphragm, which is having around 25 nanometers. So this allows only water. So these pores allows only water and other minerals, but does not allow most of the any cells and or any proteins which are larger in size. So coming to here in the filtration unit, you can see that these larger proteins such as you see the albumin. Albumin is the protein which is the smaller protein which is having 70,000 Daltons. This albumin usually which is not allowed to enter, but the proteins which are lesser than 70,000, such as if you take the hemoglobin is having 68,000 Daltons, which is allowed to pass, but albumin does not allow to pass, and the proteins which are larger than the albumin, which are having more than 70,000 Daltons, are also not allowed. That means here the pore can allow only the proteins which are 68,000 Daltons or lesser than the 68,000 Daltons. That means the 70,000 acts as a barrier, and which does not allow the albumin to come out. So if albumin, in any case, if you observe albumin in urine, it is considered to be as albuminuria, which is a diseased condition. In some kidney diseases, you can observe the passage of albumin, right? And in some kidney diseases, here if there is a severe damage, you can also observe the blood cells in the urine. But usually this is the glomerular filtration barrier which does not allow any of these things to pass through the filtration unit. So this is the term structure of the filtration unit. Right. So what is glomerular filtration pressure? So when the process of glomerular filtration is carried out, here you can observe the generation of pressure, which is called as glomerular filtration pressure. So what is this glomerular filtration pressure? So you have afferent arteriole which brings the blood to the glomerulus, and efferent arteriole which takes out the blood to the vasa recta. Then you have this is the glomerulus, and this is the Bowman's capsule. So when blood passes through here, afferent arteriole is larger in diameter compared to the efferent arteriole. So afferent arteriole is having large diameter compared to efferent arteriole. So it is wider and this is narrower. So you can see if anything, this is blood, when the blood comes through the wider one and enters into the narrower one, so usually there is pressure generated. So because it is coming from the coming in large volume but entering in a smaller volume. So due to the difference in the diameter of these two vessels, what happens? There is a generation of pressure which is called as a glomerular hydrostatic pressure. So this is called as a glomerular hydrostatic pressure, which is around it is 55 to 70 mm of Hg. So this mercury pressure, mm of Hg pressure, the filtration process, blood comes out through this filtration unit. Already we have seen this filtration unit. Here it is 55 to 70 mm of Hg pressure is maintained due to the difference in the diameter of the two vessels. So when the blood passes here, so through this filtration, again, so this is the filtration which is in the down arrow indicates that the blood is filtered in this direction. Then you have another two pressures which are applied here. One is the capsular hydrostatic pressure, because when the blood comes out, when it gets filled here, and this filled liquid, it shows the pressure in the opposite direction. That is called as a capsular hydrostatic pressure. So capsular hydrostatic pressure is in the opposite direction, and usually blood is also having the colloidal particles. Blood is having colloidal particles because of you have colloidal osmotic pressure. Colloidal osmotic pressure, which is also in opposite direction to the glomerular filtration. So glomerular filtration pressure is in one direction, down direction, and you have two pressures which are in opposite direction. One is the capsular hydrostatic pressure, and the second one is the this is osmotic pressure that is existing due to the proteins. So these so here you can observe how to calculate the GFR, glomerular filtration rate. So glomerular filtration rate is carried out by this formula, in which you have three different types of pressures. So which gives rise to glomerular net filtration pressure. So glomerular net filtration pressure is due to the glomerular blood hydrostatic pressure, which is in the down direction, and you have capsular hydrostatic pressure, which is in the up direction, and due to the osmotic pressure, oncotic pressure existing due to the proteins in the blood, which is also in against to the glomerular filtration. So usually we have already seen that glomerular filtration pressure 70 to 55 to 70. So you have taken here 60, and coming to this is the 32 is the capsular hydrostatic, mm of Hg is capsular hydrostatic pressure, and you have the third one, that is osmotic pressure, blood colloidal osmotic pressure. So if you from 60, if you reduce these two, 50, these two combinedly forms the 50, 60 minus 50 gives rise to 10 mm of Hg. So the usually glomerular pressure, glomerular filtration pressure is 10 mm of Hg. With 10 mercury pressure, the blood is get filtered in the glomerulus. So how can you calculate the glomerular filtration rate? The glomerular filtration rate can be calculated by using this constant, that is filtration constant into filtration pressure. So filtration constant, that is Kf, and so you have the filtration pressure. So how can you calculate the filtration constant? Filtration constant is nothing but it's a product of hydraulic conductivity and surface area. So due to all this tuft of capillaries, they will give surface area of nearly 1.73 square meters of surface area. So this surface area and hydraulic conductivity, if you multiply the hydraulic conductivity with surface area, then you will get the Kf value. When this Kf is multiplied by filtration pressure, then you get the glomerular filtration rate, which is around 125. So glomerular filtration pressure is 10 mm of Hg, and Kf value is 12.5, and when 12.5 is multiplied with 10, you are getting 125. So 125 ml per minute blood is filtered. 125 ml of blood per minute is filtered through this glomerular filtration. Right. So what is the importance of this glomerular filtration rate? Usually this is having much clinical importance. If the kidney is working in normal way, then the glomerular filtration rate it should be up to 60. If it is if it is reduced from 55 to 20, it indicates there is a problem, there is a kidney disease, and if it is lesser than 50, so it should be 120 to 60, it's normal functioning of the kidney. So if it is less than 60 to 20, you can say there is a kidney disease. If it is lesser than 20, it indicates the kidney is completely failure. So glomerular filtration rate can be calculated by some other formulas also. So this is having the clinical importance. Now we have observed how the blood is get filtered in the glomerulus, right? Once again we will go back and we see this how the filtration process is carried out. So blood is coming through the efferent arteriole and going out through the efferent arteriole. When blood comes through the efferent arteriole, so you have the three different types of pressures are working here. One is the glomerular hydrostatic pressure, which is in the down direction, capsular hydrostatic pressure, and blood osmotic pressure, which is in the opposite direction. By these three pressures combinedly forms 10 mm of Hg pressure, which allows the blood to be filtered. So this actually the filtered blood is collected into this structure, this Bowman's capsule, and it is then passed into the proximal convoluted tube, right. So again the remaining blood is passed through this afferent arteriole into vasa recta, right. So this is the what is the glomerular filtrate contains? What is the difference between glomerular filtrate and plasma? You can see the plasma water, the amount of water in plasma and glomerular filtrate are same. So it is around for example 900 ml of water is there in plasma. The same amount is filtered because water has no obstruction. It directly passes through the fenestrae and slit diaphragm and it comes down. Then proteins, the proteins is around, if it is 80 inside the plasma, there is a nil in the glomerular filtrate. Now proteins get filtered. And coming to other ions, the different types of ions, you can see the glucose is completely filtered, amino acids are smaller, which are also completely filtered, and you have uric acid, urea, then other components, creatinine, which are completely filtered. So these are existing in the glomerular filtrate, but no protein, no cells are existing in the glomerular filtrate. Only smaller molecules are existing. Amino acids, glucose, creatinine, urea, all these components are existing in the primary glomerular filtrate. So then this filtrate is passed through the second part of the kidney, so that is called as the renal tubules. The second half of the kidney is the renal tubules. In the first half we have seen the glomerular filtration process, and now we will discuss this filtrate, how this filtrated is passed through these the structures called renal tubules. In the renal tubules we already see that we have the proximal convoluted tubule, which is around 14 mm in length, 14 mm in length. Then you have Henle's loop, then you have distal convoluted tube, then collecting duct. So we will see these renal tubules, what is the process that is taking place in the renal tubules. In the renal tubules you can observe two different processes, that is the reabsorption, that is the selective reabsorption process, and the second one is tubular secretion. These two are in the urine formation. The first step we have already discussed, that is the glomerular filtration. Now we are studying the second two steps, next steps, that is the tubular reabsorption, and you have the third one is the tubular secretion. So one by one we will see how this process will take place. So the first part of the nephron, so that is glomerulus, and the second one is the proximal convoluted tube, so which is of around 14 millimeters of length. This proximal convoluted tubule is the area where maximum reabsorption takes place. Maximum reabsorption means around 65% of the filtrate is absorbed in the proximal convoluted tube. So here completely 2/3 of the water is absorbed, and you have 100%, so you can observe 100% absorption of glucose, 80% absorption of phosphates, and 65% of sodium and potassium are absorbed here. So this is the proximal convoluted structure. This is the proximal convoluted structure. Here you have the brush borders in the proximal convoluted tubule. Inside you have the brush borders. So this is called as the tubular side. This is the tubular side. So in the tubular side you can observe, this is the apical side. In the apical surface you can observe the microvilli like structures, so which are helping in the increasing the surface area for reabsorption. So through these microvilli, usually the different all the tubular filtrated components are reabsorbed. So here the reabsorption of amino acids, complete reabsorption of amino acid, and glucose is taking place here. 100% of glucose reabsorbs here, and you can see the reabsorption of sodium to some extent, and potassium, sodium potassium to around 65% of sodium potassium reabsorbed here. So you have reabsorption is carried out by different types of proteins, that is sodium potassium ATPase. Sodium potassium ATPase helps in the reabsorption of sodium into the vasa recta, this is the vasa recta. Here you have, this is the blood vessel side where these cells, this is the proximal convoluted cells. So from these proximal convoluted tube cells, sodium is reabsorbed by sodium potassium ATPase. Coming to how these HCO3 minus ions are also reabsorbed. Usually in proximal convoluted tubules, the H plus ions are usually they are secreted by the proximal convoluted tubule into the tubule, proximal convoluted tubule walls into the tubule. So when H plus is secreted, it combines with the bicarbonate HCO3 minus plus H plus forms the H2CO3. Again this H2CO3 by the enzyme called carbonic anhydrase is converted into this is converted into H2O plus CO2. CO2 is the easily diffusible gas, so it diffuses into the cells of the proximal convoluted tube and it diffuses into the blood vessels, vasa recta. So CO2 is like that. You can see the secretion of H plus ions and reabsorption of sodium and reabsorption of all other glucose, amino acids. Okay, so this is you can observe that 65% of the reabsorption is carried out in the proximal convoluted tubules, okay, which are having which are lined by this microvilli like structures, which increases the surface area, and the proximal convoluted tubule cells are having actively working cells which are having large amount of mitochondria also for carrying out. So you need ATP for sodium potassium ATPase, that's why large amount of ATP is produced. Actively working mitochondria cells are existing in the proximal convoluted tubules. Then you can observe the second one, that is the Henle's loop. So we already saw in the nephron structure that you have descending limb of loop of Henle, then you have the ascending limb of loop of Henle, then right, in the ascending again you have two different types, one is thin and the second one is the thick ascending loop of Henle, right. So this is the structure, you can see this is the from the proximal convoluted tube, the filtrate reaches to the this is the descending loop of Henle and this is the ascending loop of Henle, which is thin ascending loop of Henle, and this is the thick ascending loop of Henle. So the nature has given the wonderful structure here. So you can see the countercurrent multiplier mechanism here. So as the proximal convoluted tubule passes the filtrate here, usually the blood osmolarity is around 300. So this 300 blood osmolarity, the blood with 300 osmolarity when reaches to the proximal convoluted tube, as we saw here proximal convoluted tube, so where because of the reabsorption of water and solutes in the same amount, the 300 osmolarity is maintained here also. So with the 300 osmolarity, the filtrate reaches to the this descending loop of Henle. So this 300 osmolarity filtrate when it goes to the here, actually you can observe in the descending loop of Henle there is no reabsorption of there is no reabsorption of ions, only water gets reabsorbed here. This is the region which is having a large reabsorption of water. So when water gets reabsorbed here, so automatically what happens, the solute concentration increases and osmolarity is also increases. So when the osmolarity increases, this increased osmolar solution, so this increased osmolar solution reaches to here. So osmolarity increases by two different mechanisms, that is the counter current mechanism. So we will see the counter current mechanism with just a small gap. Okay, so when this in the counter current mechanism, what is happening? So when the filtrate, which is around 300 osmolar, when water is get reabsorbed here, the osmolarity increases to 400. With this 400 osmolarity filtrate, when it goes and reaches to this, this is a thick. This is the thick Henle's loop, thick ascending Henle's loop. Here you have sodium potassium chloride channels, NaKCC channel. So these special type of channels existing here, which pumps sodium, potassium and chlorine. So because of the pumping of the solutes here, what is happening? So here you have the interstitial region. So in the interstitial kidney, the nephrons are surrounded, in between the nephrons you have the interstitial region. So the interstitial region, usually here the osmolarity increases. So osmolarity increases due to the pumping of ions. So when the osmolarity increases here, automatically what happens, due to osmosis, again more water comes out of this descending loop of Henle. So as more water is coming, the solute gets more concentrated. That is from 400 to 700, 700 to 900, 900 to 1200. In this way, osmolarity increases. What is happening here? So when the filtrate is coming down here, because of the reabsorption of water, the concentration is going on increasing. So when the concentrated filtrate reaches here, what is happening? There is a special channel called sodium potassium chlorine channel, which is pumping the solutes. Due to the solutes are pumping here in the interstitial region, so more interstitial region osmolarity is increasing. So as this is increasing, more amount of water is diffused to this interstitial region due to the osmosis, because water moves from high concentration to, so this is having high concentration due to the pumping of the ion. So water moves, again what happens, because of the movement of water, more concentration of the solute ions increases more, up to 1200 the osmolarity reaches. And then coming to the this is the ascending loop of Henle, where your solute molecules again gets reabsorbed. This will cause again decreasing in the osmolarity. So here up to this curve, this loop, osmolarity increases, and again here what is happening? Again osmolarity decreases from 1200 to, again due to the channels, due to the ionic channels, which again diffuses the ions. Automatically the osmolar here completely only permeable to water, here permeable to ions also. So permeability of ions causes the movement of ions, and again so the concentration again goes on decreasing. So how much osmolarity reaches to 100, from 300 to 100, right? Then what happens, this again when this reaches, this is the, what we have said, this is the thick ascending loop of Henle, then it is entered into the distal convoluted loop. Distal convoluted loop. In the distal convoluted loop, so this is tubule, you can observe, so this is the distal convoluted tube where you can observe the absorption. So in the distal convoluted tube and collecting duct, there is a special mechanism of absorption of water and Na+. So maximally here you have observed 65 proximal convoluted tubule, 65% of filtrate is absorbed, and Henle's loop you can observe 25% of the filtrate is absorbed, and remaining 20% is absorbed in the distal convoluted tube and collecting duct. So we will come to this later. Actually it maintains the production of renin. So the reabsorption in the distal convoluted tubule is usually due to the renin-angiotensin system or RAS system. So this renin-angiotensin aldosterone system which implements a major role in the reabsorption process. So here you can see when the afferent arteriole enter into the glomerulus, you have a special type of structure which is called as this is juxtaglomerular apparatus. This juxtaglomerular apparatus consists of a cells called Pulkyson cells, and these are the macula densa cells. Macula densa cells are the special cells which are existing, and Pulkyson cells. Both these cells combinedly forms the structure which is called as juxtaglomerular apparatus. This juxtaglomerular apparatus actually it maintains the production of renin. So renin is the hormone which converts the angiotensin. Here you can observe that. So renin is the hormone which is produced from the kidney, from the juxtaglomerular apparatus. This renin converts the angiotensinogen into angiotensin. So the angiotensin inside the lungs it is converted into angiotensin 1 to angiotensin 2. Then angiotensin which angiotensin 2 which actually activates the aldosterone. Aldosterone then plays the important role in the process of reabsorption. So aldosterone, and you have antidiuretic hormone. So antidiuretic hormone ADH which is having key role in the reabsorption of water. Aldosterone which is having a key role in the reabsorption of so you can see here reabsorption of sodium ions and water are maintained by aldosterone and this ADH hormone. So in the distal convoluted tube and collecting ducts, both are having very important role. Here hormonal regulation you can observe. So that is ADH hormone which helps in the reabsorption of water. Then you have this angiotensin which is having very important, the RAS system having important role in the reabsorption of water. In the this collecting duct and this distal convoluted tubule, water gets reabsorbed. Water gets completely reabsorbed. The third process is tubular secretion. So this is the tubular secretion. So what is tubular secretion? Tubular secretion is the process which occurs simultaneously during in the reabsorption process. So some substances and byproducts that are produced from the metabolism which are toxic are secreted into the renal tubules by the process called tubular secretion. In tubular secretion, actually the components such as the H+ ions, K+ ions, ammonia, urea, creatinine and some histamines and some drugs such as penicillin which are get secreted. So tubular secretion occurs in the proximal convoluted tubule, distal convoluted tubule, both are having important role in the tubular secretion process. So the secretion of hydrogen ions, toxic components all takes place in tubular secretion. So actually this is the components of urine and plasma. In the urine you have actually which the volume of the urine which depends on the osmoregulation and due to the ADH hormone which are having important role in the volume of the urine. Then urine formation, the entire process of urine formation is carried out in 3 steps. The first one is glomerular filtration, then selective reabsorption, then the third step is tubular secretion. Usually your kidney is getting the 25% of the cardiac output. In the 25% of the cardiac output which is accounting for 1.1 liter per minute which is 1.1 liter per minute is actually it is filtered, and generally this filtrate is having how much filtrate is formed due to the cardiac output, that is 180 liters per day. The glomerular filtrate that is formed is 180 liters per day, and this glomerular filtrate gets reabsorbed, and your volume of the urine is decreased to 0.8 to 2 liters per day. So this is the complete cardiac output. Then the how much glomerular filtration comes, cardiac output 25% of the cardiac output accounts for 1.1 liter per minute. So this much of blood is passed through the nephrons, and 180 liters of glomerular filtrate comes, and this 180 liters get reabsorbed to form only 0.8 to 2 liters of urine per day. So this is the entire process of urine formation and how the kidneys structural and functional units nephrons work. So this is the entire mechanism we have seen. The first step we have seen the glomerular filtration, then in the second step you have seen the selective reabsorption, how the different water, glucose and all the different types of minerals, how it gets reabsorbed by the selective reabsorption, and how the toxic components are secreted by tubular secretion. So by the end, so only depending on the volume of water that is consumed by person, what is the amount of urine that is excreted. The excreted urine is around 0.8 to 2 liter per day. Thank you.
Good afternoon everyone, welcome to today's session. So we had been talking about communication skills as a part of the ESC program. We are done with aptitude, now we are talking about communication skills. So as a part of communication skills, I spoke about 4 fundamental pillars of oral communication. I explained to you the communication tree, I explained to you the importance of pronunciation. Yesterday I also spoke about the problems that we face in terms of proper pronunciation. I explained how mother tongue influence is not a factor, but regional influence is a factor. We spoke about the phonetics, how city and cat being words that is starting with the same letter, giraffe and gadget starting with the same letter but carries 2 different pronunciation or 2 different sounds. City starts with a s sound and cat starts with a k sound. Giraffe starts with a j sound and gadget starts with a g sound. And I explained to you why does this happen. It's because of English being a non-phonetic language. I explained how there are different languages which are phonetic, which means the way we spell, the way we pronounce, both are same. But when it comes to English language, the way we pronounce and the way we spell could be different. I gave you certain examples like PUT is put, but BUT is but, it's not but. So the examples that I spoke earlier, city, cat, giraffe, gadget, likewise we can have tons of examples where a particular letter may not have the same kind of pronunciation which may exist in any other word, and that is because it's a non-phonetic language. And I introduced what exactly is the reason because of which this happens. That's because of English language has different consonant sounds and vowel sounds. I explained the letters, how we have 26 letters in English alphabet system, 21 consonant and 5 vowels, but we have 24 consonant sound and 5 vowel sound. So today I am going to explain what a consonant sound is, and I will also explain the 24 consonant sounds with examples. So let's begin. So consonant sounds are the manner of articulation is how air escapes from the vocal tract when the consonant or approximant, that is vowel-like sound, is made. Manners include stops, fricatives and nasals. The place of articulation is wherein the vocal tract, the obstruction of the consonant occurs and which speech organ is involved. And vowel sound are pretty straightforward. It's a speech sound that is made with no obstruction of the vocal tract. Now when you read this particular definition on the left and as well as right, it's pretty complex to understand what does it mean. Now when we look at the various consonant sounds, it's going to become easy for you. Okay, so like I said, there are 26 letters in English alphabet, but there are 24 consonant sounds and 15 vowel sounds. So please make a note of this. Even though there are 21 consonants, but there are 24 consonant sounds, you need to understand how consonant is different from consonant sounds and how vowels are different from vowel sounds. You need to master this combination of 24 plus 15 in order to be perfect with the pronunciation aspect. Alright, so these are the sounds in English language as far as consonant sounds are concerned. I'm going to tell you how to pronounce these sounds. What I would suggest, if you're watching this on Mana TV Live, or if you're watching this on YouTube, if you're watching it YouTube Live or a repeat on YouTube, if you get the link and if you want to play it again, the way we're going to practice or the way we're going to understand this is I'm going to read each and every sound and then I will pronounce how it is done. Okay, alright, let's start the first line. The first line is, it's not P, it is P. So it's P, then it's B, T, D, K, G. Let me repeat. P, B, T, D, K, G. Second line, CH is pronounced as Ch. So it's Ch, J, Th, The, S, Z, Sh, J. I repeat, Ch, J, Th, The, S, Z, Sh, J. Fourth line, F, V, W. So there is a difference between the V and W. I'll explain to you once we reach there. It's F, V, W, H, R, Y, L, and the last line M or M, N and Ng. Any word that ends with ing, this sound exists there. Now when you look at these 24, it's pretty confusing. You wouldn't be able to figure how to pronounce these. So I will include examples to help you understand how to pronounce these sounds. Alright, let's start. The first one, I want to start with the first line. I'm going to make a mention of this here. Here we go. So if you look at these examples, every sound I have mentioned 3 examples. In the first example, the sound is in the beginning. The second example, the sound is in the middle. And the third one, the sound is in the end. Okay, so let's start. It's pot, per as in pot, topple, top. All right. Now let me add some more words so that you can understand it. So I'm going to reduce this font size so that I can add more examples with the per sound for you. All right, let's start. Picture, print, puddle. Puddle means whenever there is a water stagnation on the roads, like in a small hole or pothole, that's called a puddle. It's not poodle, it's puddle. Paint. Now I'm going to use certain words where the sound is in the middle. People, shopping, where per is in the middle, drop, now this sound is in the end, stop, top I have already used, shop, where the sound is in the end. So wherever you see the letter P, you will have a per sound, but there is an exception. For example, if the word is photograph, so here even though we have the letter per, but it's not a photograph. We don't say photograph, we say photograph, because we have PH. Okay. Now next one is B. For example, bat, bubble, cab. Let me give you examples, some more examples for this particular sound. Brick, biscuit, brim, basket. All right. Now examples where the sound is in the middle: trouble, cobble, double. Now here the sound is in the middle, the B sound. Now examples where the sound is in the end: drib, crib, nib, like the fountain pen nib, crab, we have crab. Okay, so some examples where the sound is in the beginning, sound is in the middle, and the sound is in the end. Now the next one is T sound. So let's look at certain words: table, bitter, pot. Likewise, what you need to do is you need to come up with more such examples. I just showed you how to build more examples. When you do this exercise, you end up working on your vocabulary as well. So table, bitter, pot, desk, advice, loud, kite, disclose, mask. Now when you look at this particular example, disclose, you notice the letter K is not there, but you do have the sound. So you need to be very sure you're looking at the sound and not the letter. Okay, let's have certain example where the letter will not be there but the sound will be there. Let me reduce this. For example, cat, okay, cascade, dislocate, locate, locket. Now here both the letters C and K are here. Here the letter K is not there, but still we have the sound which is K, like locate, dislocate. For example, disc. Even though the letter K is not there, but the sound K is there. So this particular letter, when we look at as an alphabet system, it's just a letter, but when we look at it as a sound, it's a K sound. So don't look at it as a letter K, but look at it as a sound. This is the fundamental aspect which you need to understand when it comes to the pronunciation in English language. You may not have exactly the same letter, but you need to understand what does the letter signify in terms of sound. Okay, say for example the K, we have examples on your screen which is dislocate, locate, locket, disc. So none of these words, or for example cascade or cat, none of these words have the letter K in it, but still it has the pronunciation which is K. So once you master this, you will be able to understand the importance of the consonant sound. Let me change the font size for you so that it's easier. The last one of the first line, which is a G sound, goat, magnify, big. Goat, magnify, big, sorry. Now the next set of sounds that I'm going to talk about is ch, j, th, the. Only 4 I'm going to take, rest I will pair it together later. Ch, for example, chain, discharge, march. Now there is an important point that you need to remember. Okay, so you will think CH, if it's together, that means it's a ch sound. For example, chain, discharge, charge. All right, so that means this. For example, some more example: perch, search, chin, cheek, cheer, chair. So all these words has CH, that means it's a ch sound. But what if I have a word which is this? What if I have a word which is this? A word which is CHEMISTRY. Can I say chemistry? No. The pronunciation is chemistry. Now here, this is CHROME. Can I say Chrome, like Google Chrome? No. The pronunciation is Google Chrome. So when you have a word, when you're comparing that, I have CH here. So let me remove this. So when I have CH, I say chin, cheek, cheer, chair. But here I say chemistry, chrome. You are obviously bound to get confused. Now the question is, why does this happen? It happens because that is how the word, the origin of the word is, that is how the pronunciation is designed. So that goes back to the root, that goes back to the origin of that particular word. The best way to understand how to pronounce these words is simple. Either you go to dictionary and look up for example. Now it may not be always possible to have a dictionary. Secondly, even if you have a dictionary, you can't understand how the pronunciation is. Now that everybody has internet or access to a system with internet, the best way to understand or learn pronunciation is Google. So I'll tell you how to do that. So open a Google page, enter the word, for example, chemistry. The moment you enter chemistry, it may not give you the pronunciation, right? So what you do, pronunciation of chemistry. What it does is it immediately opens a YouTube page, and in the YouTube page, if you click, it will immediately give you what the pronunciation is. Now if you want to have meaning as well as pronunciation, the best way to learn vocabulary along with pronunciation is just to type meaning of the word. Just say meaning of chemistry. What it will do is it will immediately show you the results from dictionary. Underneath there will be this particular icon. Let me zoom in the page so that you can see it clearly. So what I did, I went to Google, I just entered meaning of chemistry. It shows me the meaning of the word. It also gives me example. Now what I do is I need to activate my speaker. So once I activate my speaker, I need to unmute it and I need to click here. So let me try and show you. So that's a sound shift. So once you click, the speaker of your system will automatically prompt how the word is pronounced.
Chemistry. Chemistry.
I'm not sure if you're able to hear this, but every time I click, it gives me the pronunciation of that particular word. So that's an easy way to learn pronunciation if you have access to a system. So please make the best use of internet. 90% of people, the moment they get a phone with internet connection, now that Jio is giving so much of data for such less price, we use that ocean of information to watch movies, to watch songs, to watch some videos on Facebook and Instagram. Instead of wasting that time, you can do that just half an hour, 1 hour a day. But you have an ocean full of information which is available for free. So you can make the best use of it and learn even pronunciation from internet. All right, let's continue. The next word or the next pronunciation that we need to understand is j. So we have ch and we have j. J, for example, joint, budget, charge. Now pay attention. The letter J is missing here for this particular word and for this particular word. So you need to be very, very sure how to pronounce it, and the best way to learn is either from dictionary or from Google. So j, joint, budget, charge, even though the letter is missing, but the sound is existing here. Then we have th, for example, think, breathless, bath, the, this, rhythm, breathe. So B-R-E-A-T-H-E is breathe, B-R-E-A-T-H is breath. Breathe is a verb, breath is noun. Okay, now let's move forward. I'm going to take the next set of sounds. The first one is sir, seal, mistake, miss, z, zoo, disown, breeze, shallow, location, brush, that is for sure, and je, we don't have any word that starts with a je sound, but we have pleasure, measure, treasure, all these words where the sound is in the middle, and then we have beige where the sound is in the end. Now what happens usually is we make a mistake in terms of these two sounds. So let me quickly explain what do I mean by that. So I'm going to talk about the first one. For example, if I have the word which is student, a lot of people make a mistake and they pronounce this with a sh. Student. It's not student, it is student. Alright. Now when I have this particular word which is zoo, disown, breeze. Now this is a z sound. For example, zebra. For example, zone. For example, zeal. Okay. Now what people make a mistake is they replace the z with a j. So what they do is they pronounce this as zebra, John, Jeel. So please don't make a mistake. The moment you replace the z with a j, it's a mispronunciation. It's not zebra, it's zebra. It's not John, it is zone. It's not Jeel, it is zeal. It's a z sound. Another mistake that people do is where they add a z sound where it's not needed. For example, listen. Now the listen word pronounced as l, e, s, li. So let me add a dash after that so that it's easier for you to understand. Okay, it's pronounced as li, s, n. Listen. They replace the s with a z and they say listen. It's not listen, it's listen. Even if I add ing, it's listening. You are not listening. I'm listening to music. It's not listening, it's listening. Clear? So don't make that mistake there. Now as far as the sh and j is concerned, let me add it up here. So we have shallow, location, brush. Now if you look at this particular word, the letter S and H is missing. But every word that ends with tion is not sh sound. For example, let me add an example here so that you can understand. So every theory that I'm going to talk about, I'm going to give you an example. For example, station. Now when I have station, I have stay, shin. The tion, basically I can say shion. Station, right? So tion means sh. Location, station, now dislocation, all these words, tion. Now imagine if I replace the word, I keep tion, but I replace the first four letters. Here what happens is, instead of saying question, I can't say question because tion is sh sound. No. When I have the word question, the tion becomes ch, n. So it becomes question. Alright. So please keep this in mind. Every word is pronounced differently. You can't apply the same rule of law. Now j sound, for example, pleasure, measure, treasure, beige, all these are the words where you have the j sound. Okay. Now let's move on to the next set. F, as in fun, often, tough. Now look at this. I have the pronunciation of fur, but the letter F is missing. For example, if I have the word which is photograph, photography, photographer. So anything PHO here, it carries the function of a fur, but the letter F is not there. So you got to be careful there as well. So you need to understand how it is pronounced. Clear? Victory, level, brave, window, swift. That is the W. So now pay attention to way I pronounce or the way I make a difference between V and W. So when the moment you have a letter which has the V, it's a V sound, and the saying is bite your lips, kiss your, bite your V's and kiss your W's, which means if you have a V, you will bite your lower lip. V, for example, victory, level, brave. If you have water, William, swift, window, wherever you have W, you will make an O, for example, window. I can't say it window. It's not window, it's window. So bite your V's and kiss your W's. That is a fundamental difference between the V sound and the W sound. Alright, let's move on to the next. We have H, R, Y, L. H, for example, hollow, adhere. So wherever you have the H sound, you may or may not have the H. R. Now this R is a soft R sound. It's not R. We can't call it as ring, market, charter. No, that's not how it's pronounced. It's a very soft sound. Ring, market, charter, chapter. All right. Year, yard, mayor, toy. L, listen, island, bottle. And the last set of sounds in consonant, M, for example, money, homework, groom. N, number, hunter, listen. Ng, every time you have the letter N and G together, that's an ing sound. For example, English, ringing, ring, listening, anything that is with continuation form, ing, singing, dancing, writing, painting, playing, you have the ing sound in the end. Alright. So with that, we have all the 24 sounds done. Now what we're going to do in tomorrow's session is we're going to have a list of words where all these sounds are present, and we're going to practice it, and I will also help you to identify where to find these sounds. Alright. Whatever words you have which you are not sure how to pronounce, please send that to me. I will help you understand how to pronounce these words. So thanks for tuning in for today. I'll see you guys tomorrow. Bye-bye. Good afternoon, welcome to today's session. This is brought to you by AP State Skill Development Corporation, and we are conducting this program especially for the employability skill centers. There's already a classroom session which has already started in various districts in AP, and we are also combining the blended training methodology which is online. You're watching this live on Mana TV as well as the YouTube channel of Mana TV. Alright, so let's begin. So in the last session we spoke about the consonant sounds. I explained to you sounds in English language, since we are speaking about oral communication. I explain how we have 26 letters in English alphabet system. There are 21 consonants and 5 vowels, but we have 24 consonant sounds and 15 vowel sounds. So 26 letters that you see, those are mere letters, but here we are talking about sounds. So we have 24 consonant sounds compared to 21 consonants, and 15 vowel sounds compared to 5 vowels. So vowel sounds or consonant sounds are different from a consonant or a vowel. Okay, I explained to you the 24 consonant sounds. I showed you the list as well as the example. I just want to take you through a quick recap to explain this again. So we have p, b, t, d, k, g, ch, j, th, th, s, z, sh, zh, f, v, w, h, r, y, l, m, n, and ng. So that's 24. I showed you examples of the 24 consonant sounds. So we have p sound, for example, pot, topple, top, b sound, bat, bubble, cab, t sound, table, bitter, pot, d sound, desk, advise, loud, k, kite, disclose, mask, goat, that's g sound, goat, magnify, big, ch, chain, discharge, march, j, joint, budget, charge, th, think, breathless, bath, the, this, rhythm, breathe, seal, mistake, miss, zoo, disown, breeze, shallow, location, brush, sound, pleasure, beige, fun, often, tough, victory, level, brave, sound, window, water or swift, hollow, adhere, for example, ring, market, charter, yard, mayor, toy, listen, island, bottle, money, homework, groom, number, hunter, listen, ng or the ing sound, English, ringing, ring. So these are the examples which I showed you. Now the confusion happens between the consonant and the consonant sound. I'm just going to give you certain examples. For example, if you see the letter P, this is actually a p sound. For example, print. Now the letter P signifies p sound, but not always. For example, if I have the word which is photon, now here the letter P needs to be combined with H and it becomes an F, the first sound. For example, if I have the word photograph, again I have first sound. So just because I have the letter P doesn't mean I can pronounce this as per always. Alright. I also gave you example of ch sound. For example, change. But when I have the word chemistry, ch becomes k sound. So I say chemistry, I say chrome, so I do not really, or chromium, I do not say chromium or chrome or chemistry. Okay. Likewise, there are tons of such examples. The sounds that you see here, these are mere sounds, so don't look at it as a letter. For example, sir. Now, I can have a sound which is or I can have a word where sir is used as a sir sound, s is used as a sir sound. For example, solution. Alright, but if I have a word which is island, I don't pronounce this as Island, so s is silent here. Okay. For example, if I have a word which is pressure, just because I have two s, I can't say press sir, I can't say press sir. So here double s will become sh sound, so I say pressure. Alright. So you need to be very careful how to differentiate between a consonant and consonant sound. Every word that you pronounce will have a consonant sound, not mandatorily. There are certain words there are no consonant sounds at all, there is just vowel sound. For example, I, first person I don't have any consonant sound there, right? So a letter is a consonant, but a sound is a consonant sound, so there is a big difference. So any word that you pronounce, if the consonant sound is not fitting properly, that means you are making a mistake. Now, what are the common mistakes that we end up doing? We do a sound shift. So instead of using a particular consonant sound, we make a mistake and use a different consonant sound. These are the common mistakes or common problems that we face. We do a shift between per and fur, ver and were, sir, z, sir, sh, j, z. So we interchange this. So let me copy this and I will tell you what do I mean by this. I am going to show you some examples. Okay. All right, let's begin. For example, if I have the word which is print, lot of people pronounce this as frint. So that is where the mistake happens. Okay. There are some people who cannot pronounce the per sound, they replace that with the fur sound. For example, if I have a word which is face, they replace that and say pace. Now face is different, pace is different. Pace means speed, velocity. Face means what you see in a person. So when you make this mistake, it leads to change in meaning as well. Okay. Next, I have the word which is victory. They pronounce this as victory. Now remember what I said. If you have the letter V, you need to bite your lower lip. It's victory. And if it's W, you need to make a O out of your lips. So you say victory. No, it's not victory, it's victory. If I have the word water, then I say water. If I say the word vase, flower vase or flower vase, I say vase. If I use the name William, so I make a O out of my lips, I say William. Winter. So it's winter, it's not winter. Okay. Let's move on. Sir problem. So I have a word which is seal and they replace that with zeal, z sound. For example, if I have the word listen, they pronounce this as listen. It's not listen, it's listen. And the mistake also happens the other way around. For example, z and j is a problem. For example, if I have the word zone, they pronounce this as Joan. If I have the word which is page, they pronounce this as pays. It's not pays, it's page. Searcher problem. Now this happens because of regional influence again. For example, send, and they pronounce this, so if you make a mistake you will end up pronouncing this as shend, shend it. It's not shend, it's send. So these are the common issues that we face in terms of pronunciation. So the best way to learn pronunciation is to pick up words and then break them into consonant sounds. I will tell you how to do that. Now let's read these words for understanding the pronunciation. I am going to pronounce the word, and if you're watching this on YouTube or Mana TV, doesn't really matter. I want you to repeat after me. And let's be honest, I can't see you, but I want you to put the effort and pronounce it. Let's start. Tariff, dislocate. Now before I pronounce, let's do this. I'm going to pause here for a minute so that you can make a note of all these words. If you're watching it on YouTube in your system, you can either take a picture or you can take a screenshot. If you're watching it on television, please make a note of it. If you write this down on your notebook, it will be easier for you to remember. All right, let's start. Tariff, dislocate, possibilities, leverage, discrimination, environment. It's not environment. Please stop saying environment. It's environment. The next is government. It's not government. Don't say government. It is government. Plurality, determination, derivatives, apartment, disagreement, dislodge. COUP is coup. It's not coop or coup, it's coup. Isolation, quarantine, gesture. A lot of people pronounce this as gesture. It's not gesture just because the letter G is there, it is gesture. Against. Don't pronounce this as against, it's against. Abbreviation, annihilation. I'm going to repeat the words: tariff, dislocate, possibilities, leverage, discrimination, environment, government, plurality, determination, derivatives, apartment, disagreement, dislodge, coup, isolation, quarantine, gesture, against, abbreviation, annihilation. Some more words for you. Distance, extra. A lot of people mispronounce this word extra, they say ekestra. It's not ekestra. So let me break down some of the words to make it simple, to make you understand how to pronounce it. Alright? So this is the word. If I have to break it for your quick understanding, it's extra. It's extra. Now what mistake people do is they pronounce this as ekestra. So this is wrong. It's not ekestra, it's extra. Alright? Environment, environment. So this is the correct pronunciation. Environment. and the mistake that you end up doing is you end up pronouncing environment. Now this is wrong. It's not environment, it is environment. So please make sure you're pronouncing it correctly. Another word, against. Now how do I pronounce this? Against. Now the mistake that you end up doing is you end up pronouncing this as against. It's not against, it's against. Government. How do I pronounce this? It's government. And you pronounce this when you make a mistake as government. So don't say it's government, it's government. Environment, against, extra. Alright, let's go. Training, paper, popular, significance, domain, competency, competition, repetition, loyalty, strange, dominant, vibrancy, chronological, pictorial, confirmation, technology, accrual, gratuity. It's not gratuity, it's gratuity. Alright? So when you have all the consonant sounds in front of you, please write these sounds in Telugu right next to it so that you can understand. So I'm going to repeat these sounds so that you can make a note of it. The first one is per. So you can write it in Telugu so that you can understand. Per, b, t, d, k, g, ch, j, th, the, s, z, sh, zh, f, v, w, h, r, y, l, m, n, ng. Okay? So if you're watching it live, if you felt that I'm too fast, go back to YouTube, replay this video and write it down. And the next slide, you will have the examples. So these are the entire list of consonant sounds. Now what we're going to do is we're going to read a particular passage to make sure that we are understanding it right, and we'll pick certain words from the passage and we'll have a quick reading exercise. So let me look up something which is relevant for all of you. Okay, the internet doesn't seem to be working, so let me look up something from my database here. Alright, here we go. Let's start. Laws of nature are not commands but statements of acts. The use of the word law in this context, it's not context. So don't make a mistake there, it's not context, it's context. The use of the word law in this context is rather unfortunate. It would be better to speak of uniformities in nature. this would do away with the elementary fallacy. What do you mean by this fallacy? Now I can give you the meaning immediately, but I want you to look it up in dictionary.com or a dictionary book. So please put the effort of learning these words, vocabulary, so that you can use these words later. And how it's pronounced? Fallacy. F-A-L-L-A-C-Y. This would do away with the elementary fallacy that a law implies a lawgiver. If a piece of matter does not obey a law of nature, it is punished. On the contrary, we say that the law has been incorrectly stated. Alright? When you have a passage to read slow and try to pronounce the word properly so that you understand. Passage number 2, this is reading practice. At this stage of civilization, when many nations are brought into close and vital contacts for good and evil, it is essential. Now you see this word, it's not essential, it's essential. So instead of s sound, we have a z sound here. It is essential as never before that their gross ignorance, it's not gross. When you have this word, so let me quickly show you an important aspect which you need to know. I have a word which is gross. Now this word can be pronounced in 2 ways. First one, gr o s. I can say gross or I can say gr o s. Okay, this is your word and this is the pronunciation. Clear? Now pay attention what I am doing. This is very important for you to understand the importance of it. Okay. Now if I am pronouncing this as gross, it means it's dirty or vulgar. Okay. If I say gross, that means it's a total before net. For example, you are earning, say for example you are working somewhere and you are earning some money and that money is 10,000 rupees. Now your gross income is 10,000 rupees. On this 10,000 there will be 10% tax deducted as at source, TDS. So your gross is 10,000 minus 1,000 tax is 9,000. So 9,000 is the net on hand, but before that it is gross, which is before the net, or it's also a subtotal. Clear? So the word is same, the spelling is also same, gross, but the way I pronounce it, the meaning changes. You got to be very careful. So let me give you an example here. The painting looks gross. Okay. So when I have, slide please, when I have gross and I'm pronouncing this as gross, that means it's dirty. Let me remove this, this will be easier. Okay. Now when I'm pronouncing this as gross, the gross income was 8,000 rupees. Gross also means big. For example, just a moment. Okay. All right. So let's look at the passage again. So I'm going to read this up again. At this stage of civilization, when many nations are brought into close and vital contact for good and evil, it is essential as never before that their gross ignorance of one another should be diminished, that they begin to understand a little of one another's historical experience and resulting mentality. It is the fault of the English to expect the people of other countries to react as they do to political and international situations. Our genuine goodwill and good intentions are often brought to nothing because we expect other people to be like us. This would be corrected if we knew the history, not necessarily in detail, but in broad outlines of the social and political conditions which have given to each nation its present character. So you see the word character. I have the letter CH and it's pronounced as K. I don't say character, I say it character. One last passage for quick reading. Today, perhaps your only association with the word polio is the Sabin oral vaccine that protects children from the disease. 55 years ago, this was not so. The dreaded disease, which mainly affects the brain and spinal cord, causing stiffening and weakening of muscles, crippling and paralysis. It's paralysis, it's not paralysis, it's paralysis. Paralysis, which is why I am in wheelchair today. If somebody had predicted when I was born that this would happen to me, no one would have believed it. I was 7th child in a family of 4 pairs of brothers and sisters with huge 23-year gap between the first and last. I was so fair and brown haired that I looked more like a foreigner than a Dawood Bohri. I was also considered to be the healthiest of the brood. Okay, so when you have a paragraph like this, it will allow you to practice. So that's all about the consonant sound. You can replay the video on YouTube and practice these words. What we're going to do next is understand the vowel sounds. Now, before we go ahead and talk about vowel sounds, I just want to leave you with the information that we are only going to talk about 3 different kind of vowel sounds: long vowel, short vowel and diphthong. Even though we have triphthong and some more categories, it's not really practical for quick understanding, so we will limit our learning only to these 3. Now, as a part of your practice, what I want you to do is take any of these words which is listed. Say for example, let me just take 2 to 3 words. And I'm going to break this one by one to understand the consonant sounds. The best way to do that is pick a word and identify what are the consonant sounds here. So first one is apartment. Apart, par, r, t, m, n, t. Apartment. So these are the consonant sounds in this word. Next, disagreement. D, s, disagreement. So we have g sound here, then r, disagree, m, n, t. Disagreement. Then the last one in this list is dislodge. So it starts with a d sound, d, s, l. Now you see the letter D. but it doesn't mean that the sound exists here. So please don't get confused there. Okay? D, S, L, J. Even though the letter J is absent, but this letter G carries the J sound. Okay? So when you are able to break these, so let me expand it. When you are able to break these into all the consonant sounds which is available in that particular word, you will be able to master, or you will be able to understand how consonant sound works. So apartment, a is a vowel sound, so we left that. Apartment. Disagreement, D, S, G, R, M, N, T. Disagreement. Dislodge. Now this is an amazing example. Dislodge, even though we have the letter D, but we have the sound D only in the beginning. We don't have the letter J, but the G carries the function of J. Likewise, you need to break these words into all the consonant sounds so that you understand it better. So when you have the consonant sound written in front of you, pick any word. While you're talking, it can be a simple word like a pen. For example, phone, computer, table, chair, anything which is around you. So try breaking it down to consonant sound and you will be able to understand and master it. Next session we will talk about vowel sounds. Now when you combine the consonant sound and vowel sound, then you will understand the entire sound structure. Okay? So whatever questions you have, please post on the comment section of the YouTube video that you're watching. You can find it online. And if you have any words where you need my help to pronounce it, please post those words. I would love to take your questions and provide you with the answer. Thanks for tuning in today. I'll see you tomorrow. Bye-bye. Good afternoon everyone, welcome to today's session. So we are continuing with the second pillar of oral communication, which is grammar. Yesterday I spoke about the various parts of speech. I gave you examples on noun. So today we're going to talk about pronoun and adjective, adverb and so on and so forth. In the later part of the session we're going to have the call lines open. So if you're watching this either on YouTube live or Mana TV live, please dial the number. You will see the number little later. So you can call and ask your questions, anything in terms of pronunciation or grammar for English communication. So let's begin. We are talking about pronoun. Like I said, pronoun is a substitute for noun. You can't be using noun again and again. So that's why we have pronouns which substitutes the noun. So it's a part of speech which is used in a place of noun or noun phrase to avoid repetition. Examples of pronouns: I, you, we, they, he, she, it, me, us, them, him, her, this, those. So sentence as an example: Mohan is tired, he wants to sleep, but I want him to finish the assignment. So instead of using the Mohan name again, for example, if I say Mohan is tired, Mohan wants to sleep, but I want Mohan to finish the assignment, instead of using the name again twice, I can use pronouns, which is he wants to sleep, but I want him to finish the assignment. So when we talk about pronouns, like I said, it replaces the noun or noun phrase, but there is also an aspect of singular and plural. For example, if I'm talking about one person, I can just say him or he or she, but or him or her, he or she, or it. Now in case if the count is plural, more than one, then it multiplies. So I can't be using him, I can't be using he, she, I'm supposed to use they or them. So let's look at some quick tests to understand how to use it. The first question, Hari's mom asked Dash to clean the garage. So Hari's mom asked he to clean the garage or him? So obviously the correct answer is him. Hari's mom asked him to clean the garage. It's not garage, it's garage. A student at an all-boys high school should be on Dash best behavior. Now here there is an element of subject-verb agreement. The student, here it says a student, right? Now a student is singular. So a student in all boys high school. So the all boys high school, the entire school has only boys, but the subject here is one student. So a student at an all boys high school should be on his best behavior. So it's there. THERE is also there. THEIR is also there. Let me quickly clarify this. A lot of people do not understand and they interchange this. Okay. So there THEIR is a possession noun. There is a preposition. So please do not get confused here. Both are pronounced the same way. For example, let me zoom this. Please keep the book there. Okay. So there is basically a particular place. So that's why it's a preposition. Now when I say there is THEIR, that's a possession noun. The group will arrive at 8 p.m. And they will make their arrangement. Whose arrangement? Their arrangement. So THEIR is a possession noun. THERE is a preposition. So don't get confused there. So a student at an all boys high school should be on his best behavior. Neither Mary nor Dash knew why the store was closed. Now whenever you have neither Mary, it should be nor I. Now here is an important element which you need to understand. In case if I am talking about more than one person, that includes me as well. So I as a first person. So here is an example. So if I am talking about 2-3 people or even 2 people, and that includes me in the list, we always make a mistake. We put ourselves in first, or we use ourselves first person as I. For example, Harsha, Subhash and me went for shopping. Now that sentence is incorrect grammatically. Let me show you why it is incorrect. This is how people usually speak, right? Now there is a fundamental grammatical mistake here. So basically I'm talking about 3 people here, Harsha, Subhash and me, that is the first person. So Harsha, Subhash and me went for shopping. Now imagine if these 2 gentlemen are not in the list. Can I say me went for shopping? No, that's incorrect. Another way of making a mistake where people usually use this, me, Harsha and Subhash went for shopping. Now here again, if I remove these 2 gentlemen, it still becomes me went for shopping, which means this is incorrect. So what am I supposed to do? The correct form is I went for shopping. Now whenever you are talking about one person, that is yourself, first person, I went for shopping is fine. But in case if I am adding another person, even one or two, so it becomes Subhash and I went for shopping, or I can add more number of people, Harsha, Subhash and I went for shopping. So whenever you're talking about yourself in a group and you have to specifically mention the persons as well as yourself, you always, or the first person will always be in the end. Okay. So here neither Mary nor I knew why the store was closed. I can't say me knew why the store was closed. No, the correct form is I knew why the store was closed. That's why I is the correct option here. Next, after the training, you and dash must discuss a few things. Again, same situation. After the training, you and I must discuss a few things. Alright. Now, moving on to adjective. Now, every noun, when it gets qualified, when I'm adding a quality or a type to a noun, that is basically adjective as a part of speech. So an adjective describes, modifies or gives more information about a noun or pronoun as well, because pronoun is a substitute for noun. Examples: big, happy, green, young, fun, crazy, tree, all these are adjective. For example, the little girl had a pink hat. Now the girl is noun. So let me take this example. Okay. I hope you can see that's blue. Okay. So the blue is nothing but your noun. The little girl had a pink hat. Now if I remove this, the girl had a hat, but what kind of hat? Pink hat. What kind of girl? The little girl. So anything that is adding quality, that is describing or modifying the noun or pronoun, is adjective. Now there are different types of adjective which you need to know. Something that adds quality, for example, dangerous chemicals, green vegetables, a square box, quantity as well. So not just quality but also quantity. He has eaten 3 apples. I don't have much money. This long, thin centipede has many legs. So long, thin is also an adjective here. Demonstrative, something that is displaying or demonstrating. This red balloon is mine and those 3 yellow ones are yours. This cute baby is his brother, that cute baby is his sister. So anything that is denoting something is also an adjective. Now adjective in terms of singular and plural also you need to know. For example, my will become our, your will remain same, his, her, its. Remember I spoke about the possessions. So that's a possessive noun for adjective. Now here are some more examples to quickly test your knowledge. I dash a new bike yesterday. Please make a note of this question. Think and tell me what is the correct answer. I bought a new bike yesterday. So the correct answer is A. If you don't hurry up now, you dash late for school. Question number 2. If you don't hurry up now, you dash late for school. You have been, you are, you will be. Okay, the correct answer is C, you will be. If you don't hurry up now, you will be late for school. Number 3, I would spend my holidays in London if I dash enough money. I would spend my holiday in London if I had. Now, if you already have, then you will be in London. Had because you actually don't have. If I had enough money. Number 4, they dash water sports. They are not, they like not, they do not like water sports. The correct answer is C, they do not like water sports. I dash for shopping tomorrow. I will be going for shopping tomorrow. I will go for shopping tomorrow. I went for shopping tomorrow. Now, this is a matter of tense. Here, went is past tense. So, went is past tense of go. Now, tomorrow is future. So, I can't use C. A is a continuous form. I need not use that. So, B is a definite form. I will go for shopping tomorrow. Ram and his team, that's number 6. Ram and his team dash recently won a tournament. To answer this question correctly, you need to understand something called, now let me quickly explain this to you. I'm not sure how many of you have heard this particular term. Subject-verb agreement. Now, what do we mean by subject-verb agreement? Let me quickly demonstrate that to you. I'm going to switch over to another aspect, which is subject-verb agreement. Let me see if I have created some kind of okay, here we go. So, we are talking about subject-verb agreement. This is because the subject should always be in sync with verb. What I mean by this? If the subject is singular, I need to use a singular verb. If the subject is plural, I need to use a plural verb. Now, as simple as it sounds, we always make a mistake. So, the reason I put the Superman symbol, in case if you have he, she, it or any of singular form of verb, the singular form of subject, you will use a singular form of verb. What do I mean by this? See here, the players and the umpire is or are tired. Okay. The second sentence is the players or the umpire is or are tired. So, what do we need to do here? Now, when I'm using and, I'm combining two singular forms. That becomes plural. So, I will use the plural form of verb. Now, how do I identify what is singular form of verb and plural form of word? Let me quickly demonstrate that to you. So, if you want to use a singular verb, add S. At the end of the verb. Okay. Example, plays, works, sings. Now, in case if I have to use the plural form, now when I have to use a plural form, if I have to use plural form, drop the S at the end of the verb, which means if I have to talk about the same examples, I will remove the S at the end of the verb. So, remember it that way. If it's a singular verb, add S. If it's plural verb, drop the S. So in case if your subject is singular, use S at the end of the verb. If the subject is plural, drop the S at the end of the verb. Okay, let me show you some examples to help you understand this better. I'm going to use all singular verbs here. He plays cricket. She sings very well. It rains every evening. So if you pay attention to the verbs here, action, I am adding an S at the end of it because my subject is singular. Now if I have to use a plural verb, plural subject, they play cricket. They, or for example, she is singing very well. Now that my subject is plural, I just say they are singing very well because are is a plural form of is. It rains every day. Now there cannot be a situation in terms of a climate for plurality, so we'll leave it at that. Okay, so when you have a situation like this where you are bound to get confused, the players and umpire is tired or are tired, it should be are tired. That's because when I'm using and, I'm combining these two. Even if it's player and umpire, I'm combining. But in the second case, this is where you will get confused. The players or the umpire is tired or are tired. Here you will use is tired because this is an or situation. So if it is or, after the or, the subject, the closest subject is umpire, which is singular form. And if I have a singular subject, I will use singular verb. Okay. So when we look at some more questions, you will be able to identify more such situation. Now when you see a question, you will be able to identify what should be the correct answer. Alright. So let's move on. Let's look at this question again. Number 6. Ram and his team dash recently won a tournament. Now this is a trick question because Ram is part of the team and team is a collective form, it just won. Ram and his team have recently won? No. Ram and his team has, because it's a singular form. The subject is singular, so I'll use has. Number 7, please make a note of this question. They dash put in all the hard work for the success of the team. They dash put in all the hard work for the success of the team. Now they is a plural form. Now if I have a plural form, I will use plural verb. What is the rule? Drop the S. So I have this particular verb which doesn't have an S. So I will use they have put in all the hard work for the team. Number 8, I think we dash the training session next quarter. Now next quarter means it's in the future. I think we dash the next session, the training session next quarter. I think we begin. No, we will begin the training session next quarter. We are beginning. No, that's not the right form. We are going to begin. That is again a incorrect form because it's a transliteration. So we will begin the training session next quarter. Tomorrow we dash at 2 p.m. Tomorrow we will meet, we meet, we are going to meet, we are meeting. So number 9, this is very easy. So look at the question and think what is the correct answer. Tomorrow we will meet at 2 p.m. So A. Could you please dash me some money? Could you please borrow me or lend me? Borrow means take from me. Lend means give me. So could you please lend me some money? Number 11. I don't mind dash if you are tired. I don't mind to drive. I don't mind driving. I don't mind to be driving. I don't mind drive. So number 11, look at it, think and answer. I don't mind driving if you are tired. So option B. They arrived dash we were having dinner. They arrived while we were having dinner, when we were having dinner, during we were having dinner, for we were having dinner. So number 12, think what is the correct answer, and meanwhile you will see the number flash on your screen, 040-2354-0326, or the toll-free number 1-800-425-4039. If you have any questions about the portions that's been completed so far, which is pronunciation and a little aspects of grammar, if you have any questions, please call and ask your question. I will provide you the answer. Alright, so let's continue with number 12. They arrived while we were having dinner. So A is the correct answer. Number 13, they have sold dash car which they won in a lottery. They have sold dash car which they won in a lottery. T-H-E-R-E there, T-H-E-I-R there. This is fairly easy. I just spoke about difference between preposition and possession noun or pronoun. But here it's a trick question. The correct answer is C. In this case, they have won the car in the lottery. So denotively speaking, C is the correct answer. They have sold the car which they won in a lottery. Number 14, I dash worked for this company since 1998. I worked, I am working, I work, I have worked. Now to answer this question, we need to understand something fundamental. Now let me explain. This is one mistake where a lot of us get confused or make a mistake. From versus since. Okay, this is a preposition in terms of time. If I am using from, I should be using from when I have specifics on when did it start and when did it end. Okay, I will use since when the stated time continues. What do I mean by this? Let me show you an example. I lived in Bangalore from 2004 till 2006, which means it has ended. So I can use the word from. if I have to continue in the same way? I am living in Hyderabad since 10 years, which means I am still living there, which means the time is still continuing. Okay? So question number 14, when you look at it, I dash for this company since 1998, which means I am still working there. So the correct answer is B. I am working for this company since 98. Number 15, she dashed me to help her develop an IT training program. She has asked, she have asked. Can I use have? I just spoke about subject verb agreement, right? I can't use have because she is a singular form. She has asked me to help her to develop an IT training program. So option A. So verb types, verb is action. It signals an action, an occurrence, or a state of being, whether mental, physical, or mechanical. Verb always expresses activity, right? Anything in terms of action. Verbs in English have 4 basic parts. Now pay attention. The base form, the ing form, which is a continuous form, the past tense form, the past participle. Now something that you need to remember, we have studied all this in our school, right? We went through basic grammar in our school days, but we don't really remember the rules, but we only remember the usage. Look at it this way. There is something that has already happened, which is past. There is something which is present, a perfect present or continuous form. For example, I am talking, which means it's going on right now. Or I will talk tomorrow, that's a future tense. I spoke yesterday, and that is past tense. Any action that we are talking about, that action has to be relative to a time. Has it happened? Is it happening now? Or will it happen in the future? Okay? So keep that in mind in terms of these aspects. A verb has to be in sync with tense. Let's look at some examples. The lines are still open, so please do call. It starts with an expression, hi, I dash you in a long time. How have you been? I was seen, I saw, I haven't seen, I hadn't seen. So think and answer. What is the correct answer for question number 1? Option C is the correct answer. Hi, I haven't seen you in a long time. How have you been? Number 2, yesterday I dashed to see my grandparents. Yesterday is a past tense, so I need to use an option which is past. Yesterday I have gone. Yesterday I gone. No. Yesterday I went to see my grandparents. Number 3, some people say that it is better to dash for today. Better to, this is a proverb, right? It's a saying. Better to is living, better to living, better to lives, better to live. It's better to live for today. Have you ever dashed to Canada? Now have you ever basically means, it's a past tense. Have you ever been to Canada? Being is a state. Been means if there was an action involved there. Albert doesn't like dash on weekends. Albert doesn't like working. Albert doesn't like to work. Albert doesn't like work. Now doesn't like work doesn't make sense, so our answer 1 and 2 are correct, so option D is perfect. He occasionally is a headache in the morning. He occasionally should be a headache in the morning. He occasionally might be, could be. Now this is in terms of an adjective, so all of the above are correct. So we have various such questions. You can look up simple tests online as well. You will find tons of questions. The best way to learn is to test yourself and find what is the correct answer. We cannot learn grammar in terms of rules anymore. We already learned it, but we don't remember because we don't use it. So if you remember it in terms of usage, if you keep practicing, if you keep testing yourself, that will help you remember for a long time. So grammar is something which is extensive, but you need to put yourself in use. I cannot teach you in a classroom environment. Even when the lines are open, nobody is actually calling and asking questions. So I don't know what seems to be wrong there. So in the next session, that is on Monday, I'll move on to verbal ability, where we will look at certain instances, how to solve certain questions in certain situations. If you have questions, please post your questions on the YouTube channel. I'll take a look and provide you the answer. And thanks for tuning in. Make the best use of your day. Thank you so much. Good afternoon, everyone. Welcome to today's session. I hope you had a great festival back home. So we are talking about communication skills as a part of the ESC program, the Employability Skills Center program. Now this program is getting beamed across the state of Andhra Pradesh. You can either watch it on the satellite television, Mana TV, as well as the YouTube channel of Mana TV. You can watch it live on YouTube. And in case if you have missed, you can look it up in the playlist of Mana TV and you can watch the program and pose your questions. Now, this program, as a part of the initiative of AP State Skill Development Corporation, is meant to bridge the gap between what the students have in terms of the skills and competencies and what the industry is looking for. And one very essential and critical aspect of that is communication skills. So I had been speaking about communication, where I spoke about the 4 fundamental pillars of oral communication. I am on the first pillar, which is pronunciation. Today we'll talk about the last segment of pronunciation, and then we'll move on to grammar. As the first segment of pronunciation, we learnt the sounds. We learned how there are 24 consonant sounds and 15 vowel sounds, how they are different from vowels and consonants. We have 21 consonants and 5 vowels, but we have 24 consonant sound and 15 vowel sounds. Now the importance of this vowel sound, I had been talking about in detail, the importance of consonant sound, vowel sound, everything in detail. The last session we did some practice around words, how to break it into syllables, how to break it into consonant and vowel sounds, and today we'll look it up in detail when it comes to syllable. And we'll also learn something new, which is syllable stress. So syllable is a beat of a sound, like I explained in the last segment, a unit of pronunciation carrying one vowel sound with or without surrounding consonants, forming the whole or part of word. So what I mean to say is, when it says pronunciation carrying one vowel sound, which means every vowel sound will constitute a particular syllable. So number of vowel sound is equivalent to number of syllable. Please do not confuse that with vowels itself. It's vowel sound. Let me show you an example and that will help you understand. Let me expand this a little bit so that you can see it clearly. All right. Take for example, I have a word which is country. Okay. All right. Now, how many consonants do I have? I am only talking about consonants and not consonant sounds. So I have C, N, T, R, Y. So C, N, T, R, Y, these are consonants, and vowels I have O and U. Now let's look at how many consonant sounds we have. So we have K, N, T, R. Country. We have just 4 consonant sounds. And how many vowel sounds you have? We have K, then we have E, country. So number of vowel sound will define number of syllable. So how do I break it into syllable? If I have to break this word, country. Okay. Now I may have a word where there are multiple or say more number of vowels but less number of vowel sounds. Let's quickly look at one such example. Okay, I have the word photography here. It's actually pronounced as photography. Now how many consonants do I have here? I have P, H, T, G, R, A, P, H, Y. These are the consonants. What are the vowels? I have O, then I have O again, then I have A. So O, O, A. Okay. Now if I have to break it into syllables, I pronounce this as photography. How many syllables do I have? I have 4 syllables, but I have only 3 vowels. So number of vowels doesn't signify number of syllable. Number of vowel sound signify number of syllable. So let's see how many vowel sounds do we have. So I need to break it into all the sounds. It starts with the first sound, pho. It's photo, g, r, a, f, e. Okay, it's photography. Photography. So how many vowel sounds do I have? 1, 2, 3 and 4. So photography. Please remember, this is where most of us make mistakes. Vowel sounds are equivalent to number of syllables. So we have 1, 2, 3, 4. We have 1, 2, 3, 4. Photography. When you master this entire art of understanding consonant sound vis-a-vis understanding of vowel sounds, and when you combine that in terms of syllable, your pronunciation will be absolutely perfect. The reason people fail to understand when somebody else is speaking is because of 2 to 3 reasons. One is you do not have the right pronunciation. One word may sound like something else, and we make a mistake in terms of comprehension. Grammatically, you may not be saying the right thing, and again in terms of tense, in terms of verb, singular, plural, you make a mistake and it conveys a different meaning. You may not be using the right word in terms of vocabulary. When I talk about vocabulary, I'll give you a lot of examples where we end up using wrong words without understanding the context. And then we have fluency. Now fluency will come when you have the right pronunciation, right grammar, and the right vocabulary. Okay, let's continue. So we looked at example. So pen has one syllable, pen. Then we have pencil, two syllables. Then we have computer, three syllables. And then we have technology. Now how do I pronounce this? Technology. It's technology. And there are four syllables here. Okay. The point that I was making in terms of the last session was there are certain words which has pretty much the same pronunciation. Some of the word may have the same spelling, but it needs to be pronounced differently, and that is what it denotes differently in terms of parts of speech and in terms of context. Let me give you example that will help you understand. We have a word which is project. I gave this example earlier as well. I can use this on a sentence, and it says please project the presentation on the screen. It's not in the screen, it's on the screen. I can either use this particular sentence. Let me change the color so that you can understand that this is an example. Or I can say, please now this particular word is common between both the sentences, right? This is what we are talking about. Now when I am using the first sentence, I am supposed to pronounce this with a stress where I say project. This is the word, but I need to stress on the second syllable. There are two syllables, right? But I need to stress on the second syllable. When I do that, it means it's a verb. Now that's a rule of pronunciation. When I'm stressing on the second syllable, it's a verb. Okay? When I'm stressing on the first syllable, say for example, I'm stressing on this particular syllable, the first syllable, which is pro, that becomes a noun. This particular rule applies to every word which is spelt the same, but the shift of stress, I can either stress on the first syllable or the second syllable. So let me move this down so that we have the second example as the first one. So when I'm stressing on the first syllable, it becomes a noun. That means please submit the project. I say project. This is project. Here I say please project the presentation. Here I say please submit the project. So when I say project, that becomes a noun. When I say project, that becomes a verb. So when you're shifting it, and there is a change in terms of the vowel sound as well. When I say project, I'm using per, r and o, project. When I say project, I'm using per, r, o. So when I have project, it's an o sound. When I have project, I have an o sound. But the bigger aspect which you need to understand is the stress on which syllable. Like project and project, there are other examples. For example, subject. Okay, I'm going to move this down so that I can use the noun as the first example. So let me use the example. biology is an interesting subject. I am stressing on the first syllable, so I say biology is an interesting subject. I'm stressing on the first syllable. Okay. Now I'm using another example. Please don't subject the students to any tests. So here my stress has moved to the second syllable. For example, when I say the exam is scheduled at 4 o'clock, the timings is subject to change depending on the circumstances. So that becomes a verb. Okay. Likewise, there are tons of such words where the shift in the sound will lead to change in the meaning. It could mean a noun, it could mean a verb. All right. Now, one word where a lot of us make mistake, where we do not have complete clarity, is this particular word. Okay. Now, let me get rid of this example here. Let me explain what are the two different types of pronunciation. I can pronounce this as now first of all there are two syllables, right? All right. Now I can either pronounce this as k or n, then tent. I can either pronounce this as content or I can pronounce this as content. So content, content. We don't really understand what to be used where. That is where we make a mistake. Now when we pronounce this as content, the meaning it means an ingredient or index. For example, please give me the content for the training. Okay. Now when I say content, let me change the color here. Now when I say content, this means being happy. For example, are you content with the training? Okay. Now that makes a big difference, right? So we have the word content. I break it into two syllables. When I pronounce this as content, it means ingredient or index. When I pronounce this as that means happiness or being self-satisfied. So these are the aspects that you need to clearly remember when you pronounce the words. Okay. Now this is what syllable stress is all about. In linguistics, stress is the relative emphasis that may be given to certain syllables in a word. So whenever you are stressing on a particular syllable, that means it's syllable stress. Now there are certain rules to syllable stress. What are they? There's something called penultimate and there is something called anti-penultimate. So I'll talk about anti-penultimate later. What I want you to do is draw this diagram on your notebook to make a note of it. Penultimate means last but one or second last, right? So this is the word ending. What do we mean by word ending? So these are the word endings. There are a lot of English words that will end with any of these. Now when the rule says when a word ends with these as ending, the stress should be on the second last or the last but one syllable. Let me show you an example that will help you understand what do I mean by this. Okay, we are learning about, let me bring this down. Which rule we are looking at? We are looking at penultimate rule. When you have any word that's ending with IC, IOUS, EOUS, SION, TION, the stress should be on the second last syllable. So let's take a quick look at it. Okay. If I have a word which is panic, I will quickly change the format so that you can understand this better. Panic, tragic, magic, any more words that ends with IC? Picnic. Okay. The rule says in case if you have any word that's ending with IC, the stress should be on the last but one syllable. So let's break this. Panic is panic, which means I will stress on pa and it's pronounced as panic. Tragic, tragic, I will stress on tra. Magic, I will stress on ma. Picnic, I will stress on pick. Let me bring this down. Okay. Now what if I have a word which has more than two syllables? Then what happens? Let's take a look at it. Geographic. How many syllables do I have? Geographic. And the rule says if I have a word ending with IC, I need to stress on the second last syllable. So I'll pronounce this as geographic. If I have another word, photographic, somebody has a photographic memory. So what are the syllable break? It's photographic. And since it's ending with IC, I will stress on gra. So whatever is the word ending, like you saw, look at the word ending and stress on the previous one. So this is the word ending syllable, this is the previous one. Okay, let's look at IOUS now. Examples: pious. Now since this itself is a complete syllable, so it will not apply here. Okay. Conscious. How many syllables do I have? 2. And I will stress on conscious. Okay. Precious. How many syllables again? Precious. I will stress on pre. Same thing applies for EOUS as well. For example, I have a word gorgeous. So gorgeous, 2 syllable, I will stress on gore. SION, tension, pension. So how many syllables in tension? 2. Tension, I will stress on 10. If I have pension, I will stress on pen. So basically wherever I have this particular word ending, I will stress on the previous syllable. TION, again the same example. Station, so I will stress on stay. If I have more number of syllables, information, first I will break it, information. So where do I stress? I will stress on may. Information. If I have the word question, how many syllables? 2. Question. Alright, and I will stress here, question. Clear? So the rule says if I have a word which is ending with any of these, the stress will be on the previous, the last but one. The second rule is anti-penultimate. Now what do we mean by anti-penultimate? In penultimate we have from the end the second one, anti-penultimate is third one. So the dot has moved, which means it will be the third one from the right. Now what are these sounds? Let's quickly take a look at it. These are the word endings. Alright, so let's take a look at certain words where it ends with CY. For example, policy. How many syllables? 3. Policy. Now here the rule says I need to stress on the third from right, which means I will stress on PO. I just bought an insurance policy. Okay. TY. What if I have a word which is city, which only has 2 syllables? It will still take the stress on the first one. Okay. ICAL. Geographical. How many syllables do I have? Geographical. Now this fickle is coming up to 2 syllables, right? But this will still be combined as word ending, and this is the stress. Geographical. PHY. My favorite word. Photography. How many syllables? Photography. So this is my ending. I will stress here. Photography. GY. Technology. How many syllables do we have here? Technology. This is the ending. So I leave one, then I go to the next, and I pronounce this as technology. Meter. We all pronounce this as thermometer. Thermometer. It's not thermometer. It's thermometer, right? Now meter is pronounced as meter. It's thermometer. It's not thermometer, it's thermometer. So I will pronounce, or I will stress here, because meter itself has 2 syllables. Clear? So when you work on these aspects of syllable stress, and when you understand these rules, you will be able to not only work on the pronunciation aspect but also on vocabulary. What I want you to do is make a note of these word endings, number 1. Write down as many words as possible you can recollect out of your general knowledge of English communication. For example, I have the word which is ending with IC. Like I said, picnic, traffic, magic, tragic. Likewise, how many words can you think of? Write down those words, then practice the pronunciation. Alright, so these are the word endings. I want you to write at least 15 to 20 words for each word ending. IC, IOUS, EOUS, SION, TION. Then CY, TY, ICAL, PHY, GY, meter. I'm going to pause here so that you can make a note of this. And when you work on these words, that will also become a part of your assignment and you will learn vocabulary as well. Alright, so I hope this was helpful. Now, pronunciation recap, we learnt about communication tree, how we need a language broken into sentences, sentences into words, words into sounds. We learnt about consonant sound, we have 24 consonant sound and 15 vowel sound. We also learnt syllable, which is a unit of sound in every word, and syllable stress. So, we are done with the first pillar. Now, we move on to the second pillar, which is grammar. Now, what do we mean by grammar? It's a system of a language, rules of a language. Now, why do we face problem in terms of grammar? That is because of mother tongue influence. For example, if I'm thinking in a particular language, I do a literal translation to any other language that I'm speaking in. So what happens is the word order gets changed. When the word order is changing, it leads to grammatical issues, it leads to comprehension issues, whoever is hearing you or listening you. So when we are thinking in a language, we cannot directly translate or literally translate to any other language. That it doesn't work like that. For example, I spoke about this particular Telugu word, which is Yendukante. I hear a lot why because when people talk they keep using why because. That why because they use because they are using a Telugu word directly translated into English. Please don't do that because it does not make sense, right? Like we ask what is your good name. Now there's nothing called a good name or bad name, it's just a name. So this happens because of mother tongue influence, and mother tongue is a language which we learn from childhood, and that is a language in which we are thinking, our subconscious mind. Alright? So it leads to a change in word order, it leads to loss of sentence integrity, misinterpretation and miscommunication. Now we need to understand the parts of speech. I'm going to shift over to another module which I have prepared for you guys. So we just saw that it's a rule of a language. Are there rules in English language? No, in fact no language has rules, but it's a system that you need to follow. Okay. Now common issues that we face in terms of grammar, like I said, mother tongue influence. Now we need to understand the parts of speech. These parts of speech exist in every language. So we have parts of speech. I have written down the parts of speech along with examples. The first one is noun. Noun is name, place, animal, thing. Now a city name or a person's name is all noun. Then we have pronoun. Pronoun is something that replaces a noun. Instead of using the noun again and again, I can use a pronoun. Adjective is something that qualifies the noun. For example, noun is Ravi, pronoun is he, adjective Ravi is a passionate leader. So what kind of leader? Passionate leader. Verb is anything that is an action. So he is driving his new BMW car. Like adjective qualifies the noun, adverb qualifies the verb. How is he driving? He is driving very fast. Then we have preposition. Preposition, like the word goes, position. So here the position in terms of geography, that means the place, also the time. So basically time and place. Ravi will leave for London at 8 p.m. So whatever you see is underlined in these examples are basically the parts of speech. Interjection, wow, wow, he will fly business class. It's basically an expression. And then you have conjunction, anything that joins two independent sentences or phrases. For example, Ravi and his director will go to UK. It could be Ravi will go to UK and his director will go to UK, but instead of writing that, I can just say Ravi and his director will go to UK. So these are the parts of speech. Now let me explain the types. Common noun, for example, the mountain is too high to climb. Sorry, the mountain is too tough to climb. I'm sorry, I read it incorrectly. So something that is very common in nature, that's common noun. Proper noun are names. Now these names are little complicated because these are pronounced differently in different parts of the world because of regional influence. So New Delhi is a capital city. In Hindi, New Delhi is pronounced as Nai Delhi, right? In English, the country Turkey, so we pronounce that as Turkey. But in different languages, it's pronounced differently. A name of a person can be pronounced differently. For example, the name April, it's a month, right? In French, it's pronounced as Avril. The name Clement is pronounced as Clement in French. So the names are pronounced differently. That's why don't focus on the pronunciation part. These are proper nouns and these has influence of the region. Abstract, something which you can't touch and feel, that's a noun. For example, fear is an obstacle, so fear is an abstract noun. Count, the bottle is filled with water. Anything that you can touch, anything that you can count easily is a count noun. But there is also non-count noun, something which you cannot count. For example, you cannot count oil or water or air, right? Now what do you do in these cases? To count a non-count noun, you need to take the help of count noun. For example, I have water. Now this is non-count noun. Now how do I count it? I need to use a count noun. For example, I have bottle, which is a count noun. In order to measure water or to count water, I need to make use of count noun. For example, please buy 3 bottles of water. Now I can add the number 3, that's because I'm using a count noun here. Alright. Collective noun, something that is in group. For example, the team wants to celebrate. Okay. Now collective noun, you also need to understand the singular and the plural forms. There are certain word which doesn't have a plural form. For example, let me make it simple for you. Since we are talking about collective noun, I should definitely talk about singular and plural forms. The reason I use a PowerPoint because it's easier to display quickly rather than a board. Say for example, I have a word chair and the plural will become chairs, right? If I have computer, I can just say computers. If I have data, can I say datas? No, it remains data. If I say information, it still remains information. If I say furniture, it still remains furniture. So there are a lot of words which doesn't have a plural form. For example, luggage. Luggage will remain as luggage. For example, this is where a lot of people make mistake. Hair, it remains hair. If I have the word people, now people itself is a plural form. Lot of people make a mistake. Peoples, I met lot of peoples. Now people itself is a plural form. You cannot add another s to a plural form. Like child, the plural form of child is children. There cannot be a plural of a plural. It cannot be children's. So please keep that in mind, and you will learn that the more you dig into vocabulary. Okay. So singular, plural, I just gave you the example. She won a lottery for 1 crore. Plural, they are going to the market. So they is plural, she is singular. Possessive is somebody is in possession of something. I am using Rahul's bike. Whenever you have a possessive noun, there will always be an apostrophe. Okay. Compound noun is basically a word. When you combine the word, it leads to a third meaning. For example, the ceiling fan is not working. Now ceiling is a different word, fan is a different word. When you combine this, then you get a third word out of it. So that's compound noun. Okay. Alright, now let's quickly check if we understood this. I missed the bus because I was late. Identify the noun. What is the noun here? Bus. The queue was very long, so I didn't wait. The noun is queue. The distance was too long to cover. Of course, the distance is a noun here. The singular and the plural form, I just gave you certain examples. I went to the market and bought a lot of fruits. The traffic or traffics, of course it is traffic. There cannot be a plural form. I have to cut my hair or hairs, it's hair. There are so many different types of people or peoples. Now it should be types, alright. I have to buy a lot of furniture or furnitures. It should be furniture. I need help to carry all the luggage. It's not luggages, it's luggage. Likewise, it's garbage, not garbages. Okay. Now pronoun is something, like I said, which replaces the noun, and we'll look at examples of pronoun and examples that will also test you. So in tomorrow's session, I will come with a lot of quick tests that's going to be especially on noun and different kinds of noun, and we'll see if we can have an interactive session tomorrow through phone lines. If somebody can call and ask questions, I'll see if that is possible tomorrow. I'll keep you posted. In case that happens, please do participate. Please understand these programs are meant only for you and only for your benefit. So please make use of this. Whatever questions or concerns you have, if you need clarification, please post it on the YouTube channel. I'll take a look, announce your name, and provide you the answer. I hope this session was helpful. Thanks for tuning in. Have a good day. Bye-bye.
Hello everybody, welcome to this session on Introduction to IT. Today all of us are living in a world where information technology is so important. Is there anybody, whether it is a student or a working professional, who do not use IT? That's a question we should look at, and the answer is no. Everybody uses IT in some way or the other. Today it has become so important in our life, we can say that IT is a main line of our activity. whether it is for entertainment, whether it is for education, whether it is for job aspects or prospects, and also in the areas of research and development. Today we are going to look at the insights of what is IT, what it consists of, what are the components of IT, and how it is really benefiting the human beings as a whole. So, introduction to IT is like this. These are the components that are going to be discussed in this program. So, IT stands for Information Technology. It's been used as a buzzword in the industry and even in schools and colleges. It's become a craze thing, like people want to get into IT as a career, as a job prospects. Whether you are in the field of computer science, whether you are in the field of electrical and electronic engineering, or you are in the field of arts and commerce, the main destination for all the students is to get into IT. So, what is IT and how it's going to help us, and what are the components of IT? So, if you look at the components, the main components of IT are hardware and software at a broader level. But just having a computer itself is not IT. So, we need to have some software. So, what comes under this category of software? So, if you see, there is operating system and applications. So, any electronic device, whether it is a computer or a laptop or a PC or your smartphone, they all require an operating system, which is the most important component. Once there is an operating system, the device can start up. So, once a computer is ready, boot up and it is ready, and the phone is ready, what we need is the applications. When we turn on the computer, we use some applications. So, what are those applications that we use? So, most importantly, people use internet. So, when we use internet, we use browser, web browser. So, web browser is a software application which helps us to access the various websites. So, let us quickly get into see how this works. So, we just open the browser and then type the domain name. Let us suppose we type www.google.com. So, we get the web page. So, this is a application. Web browser is an application through which we can access internet. So, internet is one of the important aspects of IT, or we can call it as a revolution in IT. So, we can access any website that is useful and that gives us information. Okay. So, the components of IT are hardware and software. Under the software we have operating systems and applications. Let us also get into see what is IT. So, information system is essentially made up of 5 components, that is the hardware which we have just discussed, and software, and the database, the network, and the people. So, people form an important part of IT. Having developed this hardware, software, database, and network, it is for the people to use this information. So, these 5 components integrate into to perform input, process, and output. So, this is the core function of IT: input,